Hello, hi, namaskar everyone. My name is Deependra and I welcome you all in this one short video of the chapter Inverse Trigonometric Functions. Previously, we have done trigonometric functions. We had learnt a lot of identities, formulae, and those same identities and formulae will get extended in this particular chapter. So this particular chapter is easy and can be learnt with some simple efforts if you know the nuances of trigonometric function. And with these simple or minimum efforts, you can get a lot of marks from this chapter because easy to moderate level of questions are mostly asked from this particular chapter. Don't forget that in this one short video, we'll take care of everything. Conceptual learning, formulae, identities, and we'll consolidate all of this with a lot of previous year's questions. And all of this is being done for you at absolutely no cost. With these videos, one short videos, we are also providing you the handwritten notes and the DPPs for your practice in the real-time environment, which you can access by clicking on the link given in the description. It will redirect you to our PW app from where millions of students are already preparing for different competitive exams at affordable prices and getting the desired results. So without any delay, let's see what does this chapter offer and let's explore it. From this chapter, we'll be exploring a lot of things, but mostly what all we are going to see can be categorized into this first topic, principal value and the basics. So we'll be discussing a lot of basics, how you can understand this particular concept, this particular chapter, and then a lot of identities will get formed. So we'll be discussing all those identities thoroughly and comprehensively in these topic. And then of course there is a special category which is also known as telescoping sum or the VN method, which we have studied in sequence and series, that we'll see again here in ITF as well, because this chapter in a very well versed manner uses that concept. So we'll look at it from this perspective as well. So of course a lot of things are going to get discussed from this particular chapter, and let's see what all it has to offer. If I simply begin with the understanding of inverse trigonometric function, what does it all say? It simply means that first of all the trigonometric functions which are periodic in nature. And if they are periodic in nature, they all are many ones, sin x, cos x, tan x and their reciprocals. But the problem here is, if they are many one, we cannot find their inverse, because in order to find the inverse of a function, the function should be invertible. What does it mean by being invertible? Being invertible means it should be bijective. What is the meaning of being bijective? It means the function should be 1, 1 and onto. What is the meaning of being 1, 1 and onto? Let's explore that so that you get clarity that yes, it is the most crucial thing for a function to be defined if we want to take its inverse. So let me try and help you in understanding that particular part. For example, here we have a function, right? And let's take any trigonometric function. But the problem here is, let's say the function is defined by fx, which is defined as sin x. Now the problem is there will be certain elements. For example, you can take a lot of angles, and those angles will be, relate to a different values. But since this function is many one, and if I take its inverse, it will become 1 to many. And this relation cannot be said or called a function then, because 1 to many clearly violates the very definition of functions. Because in that case, it won't remain a function, because in order to call it a function, the inverse of sine, it has to have this particular property getting fulfilled, that every element from the domain should have a unique image in the codomain set. I hope you remember that. But that will not get fulfilled, because the problem here is, if I could take a simple example here, I hope you remember that, let's say we know, let me try and make you understand this with the graph of sin x, right? So that you will get more clarity about it. Let's say I am drawing the graph of sin x. Just give me a second, participants. So let's say this is the y-axis, this here is the x-axis, and there I'm drawing the graph of sin x. So this is how the graph of sin x looks like, right? And it gets stretched in the left side and the right side as well. So it is how the approximate version of the graph of sin x look like. I hope you're able to understand this particular part. Now, if I am asking you that, tell me, where do you see sin x being 1 by 2? So you might end up saying that, sir, at a lot of places, because there are a lot of values of x at which I can find sin x to be becoming 1 by 2. I hope you can see. Let's say this point is 1 by 2 on the y-axis. I hope you all know that at 30 degree, which means at pi by 6, we see sin x becoming 1 by 2. And of course, not just that, pi minus pi by 6, which is 5 pi by 6. There also, we see sin x becoming 1 by 2. So here, if I could find that, sir, what is the value of sin pi by 6? I'll say 1 by 2. What is the value of sin 5 pi by 6? You will again say 1 by 2. So when you define the inverse function as what we have discussed in the chapter functions, I'll say that, sir, let's say if I'm willing to figure out sine inverse 1 by 2, then what does it mean? It means I'm looking for an angle whose sine when taken gives you the value 1 by 2. I hope you're understanding my language very clearly. The meaning of sine inverse 1 by 2 is that I'm looking for an angle now. I'm trying to find out a value, the angle basically, whose sine ratio when taken gives you the value 1 by 2. But the problem here is, so now we know that there are infinite angles, for example, pi by 6, 5 pi by 6. So all these such angles, when we take the sine ratios of all such angles, the value is found to be 1 by 2. Now what will you say? Will it be pi by 6, 5 pi by 6 or any other value? Because sin x, tan x, cot x, cosec x, sec x and cos x, all of these functions are periodic in nature. So they will keep on repeating these values. So the problem is I cannot have a unique value here. So how do I ensure that the trigonometric functions, when you wish to take their inverse, then how can you have their inverse? How can you ensure that their inverse can be found? Of course, since this chapter is built on that basis only, I will do something so that it can be ensured that you can take the inverse of trigonometric functions. So first of all, I'll restrict it into a principal domain. What do I mean by that? If I remove its periodicity, if by some means I could ensure that it is not repeating itself, the graph is not repeating itself, it is not maintaining or staying the many one to, it is not fulfilling the property of being many one. And if I by some means will explore those avenues of course, but if by some means I could convert it into a 1-1 onto function, 1-1 onto. What is 1-1? 1-1 mapping. What is onto? When codomain and range are equal. So if I could do these two things, if I could fulfill these two conditions, if I could make it happen like that, then I will definitely undoubtedly say that since now the function has become injective as well as surjective, which means the function is now bijective, and if the function is bijective, it is invertible, which means its inverse can be taken. How do we ensure that? Okay, so the problem is I need to restrict it or confine it to some range, some domain, so that this problem doesn't occur that sine pi by 6 and sine 5 pi by 6, they both give 1 by 2. Although it is a principle, it is a standard fact that sine pi by 6 is 1 by 2. But what if I restrict the graph of sine x from minus pi by 2 to pi by 2 only? I repeat, if I could restrict the graph of sin x from minus pi by 2 to pi by 2 only. For example, somewhat like this. Let's say this is how I am restricting the graph of sin x from minus pi by 2 to pi by 2. Of course, after pi by 2 the graph exists. Before minus pi by 2 also the graph exists. But now I'm putting a constraint over here that I am not looking at the graph of sin x before minus pi by 2 and after plus pi by 2, which means I'm restricting or confining this graph from minus pi by 2 to pi by 2. What is the advantage of doing this? If you now are looking at this particular graph, you must be noticing that this function has become 1-1. Why? Because if I now notice all the values from minus 1 to 1 on the y-axis, they have exactly and only one value corresponding to them on the x-axis. What does it mean? That only one value on the x-axis will be giving me some value on the y-axis, and it is onto now because I have ensured that its range is between minus 1 and 1 only, and its codomain is also from minus 1 to 1 only. So when I take the inverse, the range of the function becomes the domain of the function, and the domain of the function becomes the range of the function. So if I define sin x in such a manner, that I take its domain, if I take its domain from minus pi by 2 to pi by 2, and I define its range from minus 1 to 1, then I have ensured that this function sin x has now become a function which is 1-1 and onto. I hope you are seeing it very clearly. And if this function is 1-1 and onto, which means its inverse can be taken. And if I can take its inverse, which means it has become an invertible function. Here, if I could define f inverse x, in that case, I'll write it as sine inverse x. I hope at this stage, nobody assumes it as 1 upon sine x. It is not cosec x I have written. If I were to write that, I could have written it like this, sine x whole raised to the power minus 1. So this and this are not same. They are different. I hope you're understanding it very clearly. So what my point here is, this is sine inverse x, inverse of sine x. When you say sine inverse x, what does it mean? For example, here sine inverse 1 by 2. So I'm looking for the value on the x-axis whose sine ratio when taken gives you a value 1 by 2. That is the meaning of sine inverse 1 by 2. And I hope you know, for 1 by 2, there is exactly and only one value now because I have confined it to a certain range or a domain, and that here gives me the value pi by 6, that is 30 degree. Did you get that part? So sine inverse 1 by 2 could have been anything, but in that case, this won't remain a function basically. So to call it a function, I had to ensure that it remains 1, 1 on 2. And there I have restricted it into its principal domain, which is minus pi by 2 to pi by 2, because between this particular domain, it has now left its periodicity. It is now 1, 1 and it is now on 2. And because of that, I hope I can see that sine inverse 1 by 2 can be defined uniquely as pi by 6. Now it fulfills the condition for a function to be function. What is it? From the domain of the function, all the values, all the elements should have a unique image in the codomain set. Do you remember that? I hope you are now realizing that when you define the function f inverse x, here whatever range was there for sine x, that becomes the domain, which is from minus 1 to 1, and whatever domain was there of f of x, which is minus pi by 2 to pi by 2, becomes the range. Even if you look at this particular graph, this graph still represents the graph of sine x. If I were to draw the graph of sine inverse x, it would look a little different, and that's exactly what I'll try and show you here. Look at this particular graph. Can you notice it? That if I wish to draw the graph of inverse of a function, we had a discussion in the chapter functions that all you need to do is take the mirror image of the graph of that function with respect to the y is equals to x, the line, the straight line, with respect to the straight line y is equals to x. So if I'm taking its mirror image with respect to the line y is equals to x, or if I simply use the logic, what is the logic? That, sir, the range of sine x was minus 1 to 1, so that will become the domain here. So it will be from minus 1 to 1. Do you remember that? And the domain of sine x, which was minus pi by 2 to pi by 2, will now become the range here for sine inverse x. So that will be from minus pi by 2 to pi by 2. Of course, at 0, it is 0. So this is how you will see its graph getting formed. Can you see it very clearly here? Of course, we have already removed its periodicity because that was needed to be removed in order to make it a function. And that's where it is now between minus 1 to 1 on the x-axis and from minus pi by 2 to pi by 2 on the y-axis. That is its principal range, or the principal domain of sine x is minus pi by 2 to pi by 2. I am looking for numerically smallest possible values for which all the values minus 1 and 1 are defined in sine x. And on those values, I have defined its principal range, minus pi by 2 to pi by 2. Did you get that part? I hope there is no confusion on this front. And I hope you are understanding the significance of inverse functions. They are not reciprocal, they are inverse. I hope you are able to differentiate these two. Any confusion so far? Did you understand the graph of sine x, sine inverse x? I hope this understanding is very well built by you. That here, this is something we have already discussed, so I need not explain this particular part. If I could simply make you understand the domain and range one more time, then yes, the domain of sine inverse x will be from minus 1 to 1 domain. I hope you're realizing that. And those values will give me all the values between minus pi by 2 to pi by 2. That is my range or principal range or whatever you wish to call it. Now, there are certain observations. If I could simply try and make you understand them, then what does it mean that here this is the principal branch? What is the meaning of having the principal branch here? Principal branch means that I have chosen minus pi by 2 to pi by 2 deliberately. Some of you might be willing to ask that why have you chosen minus pi by 2 to pi by 2? Can I not choose some other branch? You all can choose whichever branch you wish to choose. All you need to ensure that the function remains 1, 1 and onto. But we had to choose something. For example, the way we walk on the road. So in India, there is a rule that we are supposed to walk on the left of the road, on the left side of the road. So that's a rule. Now we all are following that rule, that tradition, that culture, that method. So that's exactly how we are defining something. So if we have defined that for sine inverse x, if we are defining its principal domain as from minus pi by 2 to pi by 2, so we'll all follow or abide by that particular rule. I hope you're understanding that particular result. So yes, you could have taken other range, pi by 2 to 3 pi by 2 or something like that, but something was supposed to be chosen, and yes, finally this was chosen and finalized, and we all follow it, we all work upon it. That is considered as the principal value branch. Did you get that part? In the same fashion, when you define the inverse of the function cos inverse x, here the principal value is not from minus pi by 2 to pi by 2. Here it is defined as 0 to pi. So from the graph of cos x, if you wish to define its inverse, the graph of cos inverse x goes from, of course, minus 1 to 1 on the x-axis, I'm defining the graph of cos inverse x. So it takes all the values from -1 to 1 on the x-axis. But here, if you now look at its value, it is not from minus pi by 2 to pi by 2, because if you look at the graph of cos from minus pi by 2, you would see that there is a problem. From minus pi by 2 to pi by 2, I can see the graph of cos x ranges from 0 to 1 only. And it doesn't cover all the values of cos x. And again, there is a problem. What is the problem? That I need to define it from -1 to 1. The second problem is between minus pi by 2 to pi by 2, it is mini 1. So if I could take minus pi by 2 to pi by 2, then it would have created some problem. But if I take the graph of cos x from 0 to pi, if I could take the graph of cos x from 0 to pi, I hope you can see it very clearly. From 0 to pi, I am seeing all the values of cos x being utilized from -1 to 1. Are you noticing it? So that's why when we are taking the inverse of cos x, which is cos inverse x, then the principal values we are considering here are not from minus pi by 2 to pi by 2. This time they are from 0 to pi. Do you get that part? I hope there is no confusion on it. Now, I hope you are able to understand some more conclusions. For example, if I'm saying here that yes, if I could define its domain, its range, they are very simple, because again, the domain has now become, the domain still is from -1 to 1 only. That is not a problem. But if you talk about its range is from 0 to pi. I hope you can see it very clearly here on this front. So if I could define it more clearly, I'll give you more clarity on this, that yes, domain is from -1 to 1 and range is from 0 to pi. Don't forget this. In sine inverse x, the domain was still -1 to 1 and as same as cos inverse x, but in sine inverse x, the range was from minus pi by 2 to pi by 2, but here the range is 0 to pi. I hope you will remember this as a difference. Right? Now, moving ahead, moving towards the next part. Now, if I could define the next function, which is what? Which is our tan inverse x. Now, I hope you remember tan inverse x is again a periodic function, but if I take its principal domain, what do I mean by principal domain? This one. From minus pi by 2 to pi by 2, this is how the graph of tan inverse x looks like. I hope you remember that. Now, and of course, the lines parallel to y-axis from pi by 2 and minus pi by 2 on the x-axis are asymptotes to this curve. If I wish to take its inverse, this is how its inverse will look like. And I hope there is no confusion on it, that at minus pi by 2, it approaches minus infinity, 10x I'm talking about. And at plus pi by 2, it approaches infinity. Of course, the left hand limit and the right hand limit I'm considering specifically. Here, what you also need to understand is that at 0, it is 0. So in the same fashion, when I'm willing to define tan inverse x, what I'll say that in tan inverse x, if this x approaches infinity, y will approach pi by 2. In tan inverse x, if x approaches minus infinity, y will approach minus pi by 2. I hope this part is properly visible and understandable, and you are getting a great clarity on this. So here, this was the graph of what? This was the graph of tan x. But this here is the graph of tan inverse x. So on the x-axis, I am taking the values, and on the y-axis, I am taking the angles. Here again, if you have noticed, this time, previously in sin x and cos x, the domain was from -1 to, sorry, yes, for sin inverse x and cos x, the domain was from -1 to 1 closed interval. But for tan inverse x, the domain, I hope you can see, the graph ranges from minus infinity to infinity. That means it will have the domain all the real numbers. I hope you can see that the function is increasing, and here the function is odd. Even if you look at the graph of sin x, the function is odd. I hope you must have noticed it here very clearly. If you look at the graph only, the function is an odd function. Did you notice it? That the function is an odd function. I hope you are noticing it, that it is symmetrical with respect to the origin. So whatever graph you are seeing of sin inverse x in the first quadrant, the same graph we are seeing in the third quadrant. Although cos inverse x wasn't an odd function, nor it is an even function, but if you look at tan inverse x, that again is an odd function. Can you see it getting clearly, forming an odd function? It is clearly symmetric with respect to the origin. The way it is drawn in the first quadrant, in the same fashion it is drawn in the third quadrant with respect to the origin. When you talk about its domain, it is from minus infinity to infinity, open interval. And when you talk about its range, it is from minus pi by 2 to pi by 2. Its graph exists between minus pi by 2 to pi by 2. Although there are some other branches of 10x, but we have taken this branch only from minus pi by 2 to pi by 2 deliberately. Did you get that part? I hope there is no confusion on it. And of course, if I could give you more clarity about its domain and range, then do remember that if I'm taking 10y from minus infinity to infinity, where y is from minus pi by 2 to pi by 2. And if I'm defining its inverse, in that case, its domain will be all the real numbers from minus infinity to infinity. And of course, here, its range is going to be from minus pi by 2 to pi by 2. Did you get this part? I hope there is no confusion on it. Now you are able to create some more sense out of inverse trigonometric functions. You must be building a lot of confidence and clarity from this particular chapter. And then if I could move ahead towards the next function, which is cortex. Now, I'll try and make you understand this function cortex as well from the graph only. So let's say here we have the graph of cortex, right? So if I could draw the graph of cortex, this is how we draw the graph of cortex between 0 to pi. So this is 0, this is pi, and exactly between 0 and pi, the other value is pi by 2. And of course, this is the principal value range which I'll take for cortex from 0 to pi. So if I'm taking the graph of cortex from 0 to pi, and if I'm willing to define its inverse, this is how the graph of cot inverse x is drawn. I hope you can see it very clearly. Whatever was there on the x-axis has now gotten into y-axis. 0 pi by 2 pi, this particular part I hope you can see here on the y-axis. And if I was seeing something on the y-axis which was from minus infinity to infinity, that portion is now clearly visible on the x-axis. Can you see it there? I hope you can see its curvature as well. Of course, it is not an even, neither an odd function, neither even nor an odd function. But if you look closely, you could draw some more deductions. What kind of deductions, students? For example, here again, it is a continuous function. It is a decreasing function, a strictly decreasing function. And there are some more conclusions. For example, the moment you see x approaching minus infinity, the moment we see x approaching minus infinity, y approaches pi. Repeat, in other words, you would say that for cortex, if x approaches pi, cortex approaches minus infinity. But opposite of it will be said in the context of cot inverse x. So whenever you're defining cot inverse x, here I'll say that in cot inverse x, if x is approaching minus infinity, cot inverse x or y will approach pi. Did you get that part? I hope there's no confusion on it. Similarly, when you see x approaching 0, x approaching infinity, then you see cot inverse x or y approaching 0. I hope there is no confusion on it. I hope you're getting a lot of clarity. And don't forget that the moment you see cot inverse x, in cot inverse x, if x becomes 0, cot inverse x becomes pi by 2, because we know that cot pi by 2 is 0. So I hope you are able to build a great sense and a great understanding here. And of course, if I were to define its domain and range, then it matches a little with cot. For example, domain is of course going to be all the real numbers from minus infinity to infinity, cot inverse x. But as cos inverse x, we had discussed that also had the range from 0 to pi, but that was closed interval. Here also, this function will also have the range 0 to pi, but the open interval. I hope there is no confusion on that. After this, let's move to the next. Here we have sec inverse x. Now, how do I personally remember the graph of sec inverse x? I hope you remember that we had a discussion of the graph of sec x. In the same fashion, we can remember the graph of sec inverse x. Of course, we know, if I could remind you the graph of sec x, I hope you remember that for sec x, we had seek help from the graph of cos x. So let's straight away start from cos x. I hope you remember that in cos x, if I am taking it from, let's say, 0 to pi, so I am saying that two things are very clear here. If I am taking it from 0 to pi on the x-axis, because as of now I'm drawing the graph of cos x. So if I am drawing first of all the graph of cos x, then I'll draw the sec x, and then I'll try and make you understand how are we drawing the graph of sec inverse x. You'll get more clarity. Of course, you can visualize it, but if you get confused, we have this particular discussion over here. So this is 0, and from 0 to pi, this is how the graph of cos x looks like. This is the graph of cos x. Now you must remember that we had a discussion that whenever cos x becomes 0, sec x will go not defined. I hope you remember that. So here at this point, which is pi by 2, the problem is cos x becomes 0, and there sec x will go not defined. So sec x will remain 1 at 0 only, but it will go or approach infinity as soon as x approaches pi by 2. Are you able to make some sense out of it? In the same fashion, when you look at this graph from pi by 2 to pi, then of course at pi, sec x will also be -1 because cos x is also -1. But from pi to pi by 2, it will start reaching minus infinity. Are you able to make some sense out of it? I repeat, this green part which I have drawn is representing the graph of cos x from 0 to pi. I hope you are able to get this part here. I hope there is no confusion on it. But of course, sec x is reciprocal of it. So if sec x is reciprocal of it, its graph between 0 to pi will look somewhat like this. From 0 to pi by 2, this will look like this. From pi by 2 to pi, the graph of sec x will look like this. Two to three things you need to consider here is that at pi by 2, from left hand side, it will approach infinity. And if it approaches pi by 2 from right hand side, it will approach minus infinity. Are you able to deduce these things? Two things are clear for sure, that at 0 it will be 1 and at pi it will be minus 1. I hope these points are very well understood by you all. Now when you draw the graph of sec inverse x, what changes are brought here? I hope you must be noticing that whatever is there on the x-axis, that is 0, pi by 2 and pi, will now go on the y-axis because it is the inverse. And in the same fashion, whatever is there on the y-axis from minus infinity to infinity, the graph of sec x doesn't exist between minus 1 and 1. So from minus infinity to minus 1 and from 1 to infinity, I'll be seeing this portion of the graph of sec inverse x on the x-axis. Are you able to digest this point? So if I could draw a few more things for you, then of course I'll be saying that here, I'm really sorry, that here at this point, this clearly is going to be the point where you must be noticing this point to be minus 1 on the minus 1. And here, let me draw this point as well. Then I'll be in a position to show things more clearly. Just give me a second, participants. Right. So I put properly posted here. There is no confusion on that. Let me just give me a second. Let me just draw this part. Okay, now things will be more clear to you. How? Let me try and make you understand that part. Now, here we go. See, look at this particular part here. Can you point this point? I hope this is a point on the x-axis. This is also a point on the x-axis. Do you not agree that from minus infinity to minus 1, I am seeing the existence of this graph? But this minus infinity to minus 1 will be there on the x-axis now because it is sec inverse x. And of course, from minus infinity, it would be reaching, I hope you can very clearly see that from minus infinity to minus 1, if I'm coming, then at minus 1, it will be pi sec inverse x. Do you remember that? Similarly, then between minus 1 to 1, I won't see any existence of this graph of sec inverse x as well because sec x does not exist between minus 1 and 1 on the y-axis. I hope you can see it very clearly. So here again, I hope you are noticing it very clearly. Then again, from 1 to infinity, I hope you can notice it very clearly. From 1 to infinity, I can see the graph of sec inverse x on the x-axis, and for those values, correspondingly, it will be taking the values from 0 to pi by 2. So if I could try and make you understand the final conclusion, it will remain very simple that from 1 to infinity, the graph of sec x lies between 0 to pi by 2. I hope there is no confusion on it. And at pi by 2, it breaks. It is, of course, an increasing function. And then from pi by 2 to pi, the graph increases from minus infinity to minus 1. I hope there is no confusion on it. I hope you are getting a great clarity here. From minus infinity to minus 1 on the x-axis, I was mentioning very clearly. From pi by 2 to pi, I was saying on the y-axis. So I hope you are understanding my words, my language very clearly. If I give you more clarity, then this is the graph of sec inverse x. It lies from minus infinity to minus 1 and then from 1 to infinity. That will be the domain. If I talk about its range, it starts from 0, reaches pi by 2, breaks here, then from pi by 2 to pi. I hope you're able to digest this part very clearly. And if you have understood this graph, I'll try and tell you the domain and range more clearly so that you get a very good and complete clarity here. I hope you must have seen that, sir, as far as the graph of sec inverse x is considered, you would always say that yes, its domain is going to be all the real values except for the values between minus 1 and 1, because between those values, the graph doesn't exist. Of course, at minus 1 and 1, the graph does exist. And when you talk about its range, of course, here, if I could define its range, then I think there is something wrong here. Okay, I'm really sorry. This is cosec inverse x. I'm really sorry. This is, yes. So when you talk about its range, I repeat, the range of sec inverse x, it is from 0 to pi, excluding pi by 2. And similarly, if I talk about the graph of cosec inverse x, it will also remain same. I'll show you. But if I'm talking about the range of cosec inverse x, I hope you remember, its range won't be from 0 to pi. Its range is going to be from minus pi by 2 to pi by 2, excluding 0. If you want to get more clarity on these two fronts, sec inverse x and cosec inverse x, let me give you one more opportunity through cosec inverse x, and you will build a great clarity on this particular concept. Let me just try and show it to you. I hope you remember we have discussed the graph of sin x. From sin x, I'll draw the graph of cos x. From the graph of cos x, I'll draw the graph of cosec inverse x. I hope there is no confusion on it. I hope 3 parts and 3 phases are very well understood by you all. I will be talking about this front, that whenever sin x is lying between minus pi by 2 to pi by 2, that will be my considerable zone. I hope you're understanding it very clearly. Now, if this is the graph of sin x, from minus pi by 2 to pi by 2, I hope it's really easy and simple for us to figure out the graph of cosec x, because between minus pi by 2 to pi by 2, if I talk about these points, this is minus 1, this is 0, and this is 1. So at pi by 2, cosec x also remains 1, but here from 0 to pi by 2, it goes like this. And again, at minus pi by 2, cosec x remains minus 1, but from minus pi by 2, 0, it goes like this. So here it approaches minus infinity, and here it approaches plus infinity. Are you getting some clarity here? Again, if I were to give you some more clarity, I have merged two figures, two graphs together just in order to make you understand it more clearly, that here, this particular region, this is the graph of here, sin x, and this graph, this particular portion, and this particular portion is the graph of cosec x between minus pi by 2 to pi by 2, because that is our principal domain. Now, if I could point out few things for you here to make you understand that if I bring cosec inverse x into picture, what all points should I carry in my mind? I'll say, look at this particular part. Here at 0, at 0, cosec x will not be defined, because at 0, it approaches minus infinity from left hand side and plus infinity from right hand side. I hope that part is very well understood by you all. Second conclusion, that here at minus pi by 2, it was minus 1, at pi by 2, it was 1. So I think I have the curvature, I have a lot of details which can be replicated here, and you can draw the graph of cosec inverse x. How? Again, now, all the values from minus pi by 2 to pi by 2, which were the domain of this cosec inverse, cosec x, will become the range of cosec inverse x. So whatever was there on the x-axis will be there on the y-axis now. I hope you understand the concept of inverse functions now. So I'll be having the values from minus pi by 2 to pi by 2. There is something wrong, I believe. I'll correct that. Don't worry about it. I'll make those corrections. I think this should be minus pi by 2. Now, I repeat, minus pi by 2 to pi by 2. These are the values on the x-axis, but when you draw the graph of cosec inverse x, these are the values will be on the y-axis. So here, this point clearly is going to be minus pi by 2, and this point is clearly going to be pi by 2. Basically, 0, minus pi by 2, 0, 0, and 0, pi by 2, but I'm denoting these points only. Now, similarly, few more things. I hope you remember that this point here, corresponding to this point here, it will be minus 1, 0, and corresponding to this point over here, it will be 1, 0. So I hope you remember it very clearly, that if I'm starting from minus infinity, so from minus infinity to minus 1, I'll be seeing the graph of cosec inverse x from minus pi by 2 to 0. Then at 0 it breaks. Then from, I hope you can see, 1 to infinity, if I'm seeing the graph of cosec inverse x from 1 to infinity, I hope you're noticing it very clearly. I'll be seeing the graph from pi by 2 to 0. I hope you can see it very clearly on the y-axis. I hope it makes complete sense that it is clearly a decreasing function which breaks, which discontinues at 0. I hope there is no, from minus pi by 2 to pi by 2 in this, minus 1 to 1 in this case, because here it is the inverse. So I hope you're not getting confused between cosec x and cosec inverse x. But always remember, whenever you have any doubt, any curiosity, you always go back to sin x. From sin x, you can draw the graph of cosec x, and then from cosec x, you can draw the graph of cosec inverse x, instead of directly drawing it. But of course, if you could remember these points, which points? Sir, it is going to be from minus pi by 2 to pi by 2. And then there are certain things which you know about cosec x. So through that also you can conclude a lot of things. But yes, don't get confused. And remember, this is how you can actually start from scratch. Because I always preached in these sessions that yes, instead of mugging up or craving the results, which may, which may confuse you more rather than always learn these things logically. So if you have learned the concept of functions, if you have understood the inverse functions, then of course you know the trigonometric functions, and from trigonometric functions you can understand the concepts and the graphs and the domain and the ranges of inverse trigonometric functions as well, especially sec inverse x, cosec inverse x as well. They don't confuse you, I believe now. So I hope you have gotten a great clarity here. If I could summarize whatever we have learned so far, then I'll give you a very standard table that will help you in generalizing a lot of results. What do I mean by that? Please pay attention. If you simply look at certain results, you will be able to conclude a lot. What do I mean by that? You will see some relation between sine inverse x, tan inverse x, and cosec inverse x. In what sense? In a sense that their range, their principal value branch is minus pi by 2 to pi by 2. Of course, there are some conditions. For example, sine inverse x will be strictly from minus pi by 2 to pi by 2, closed interval. But for tan inverse x, I'll say it will be from minus pi by 2 to pi by 2, but I won't include pi by 2 and minus pi by 2. There will be open bracket. And of course, when you talk about cosec inverse x, that will also be in the interval minus pi by 2 to pi by 2 closed interval, but I won't include 0. I hope you know the reasons. Cosec at 0 creates a problem. And here 10 at minus pi by 2 and pi by 2 goes not defined, and these are the simple generalizations. So what I am trying to help you with is that remember that these three are similar. Which three, students? Sine inverse x, then tan inverse x, and then cosec inverse x. And the other three are similar in a sense of principal value branch. What do I mean by that? Now look at these three fronts. Which three fronts, students? Cos inverse x, and then sec and cot inverse x. I hope you're realizing for cos inverse x, I can see its principal value range from 0 to pi, closed interval, both included. And then sec inverse x and cot inverse x are also from sec inverse x, I hope you can see, is also from 0 to pi. Of course, pi by 2 won't be included here. And at cot inverse x also, it is from 0 to pi, but open interval. So these three are simpler and similar, and the other three are simpler and similar. That's how you can categorize them. And that's how I personally remember them. Whenever I can get confused, the principal value range for sine, cosec, and tan is almost same. And for cos, sec, and cot is almost same. These two broader conclusions you can bring here. Similarly, when you talk about domain, domain can very easily be understood here by using a very simple logic that yes, for sine inverse x, it is going to be minus 1 to 1. Similarly, for cos inverse x, it is going to be minus 1 to 1. For tan inverse x, it is all the real numbers. For cot inverse x, it is all the real numbers, because range of the functions, trigonometric functions, is now becoming the domain of inverse trigonometric functions. I hope you remember that. So if you remember the range of those trigonometric functions, you can very easily conclude that it will be the domain of these inverse trigonometric functions. Similarly, for cosec and sec as well, you can draw these conclusions. Some simple conclusions can be understood by simple learning. Yes, we remember learnings from the chapter trigonometric functions, and those learnings are extended here without any doubt, hesitation, or confusion. Did you get that part? If you have understood whatever we have explained so far, especially if you have built a great understanding of the graphs, let's check the understanding of those graphs with this particular question. Pause the screen right now, try it by yourself, and you can assess it by yourself whether you have understood the graphs or not if you are able to solve this question. Of course, it uses the concepts of quadratic, it uses the concepts of graphs, it uses the concept of inequalities. Wavy-Curve method can also be used if you want to, and then you can finally come to the conclusion. But the most crucial part is going to be whether you know the graphs or not. This is a classic question on that. Now, how do we solve it? If you have tried doing it by yourself, I'll say this is a standard question. It says all x satisfying the inequality. This is the inequality. So to keep it simple, to keep it understandable, and to avoid redundancy, or to reduce my efforts, can I not say for a while, let's say that I can replace for a while cot inverse x by t. So for a while I am replacing cot inverse x by t. I hope there is no confusion or doubt on that. So this quadratic now, which was there in cot inverse x, looks like a quadratic as t square minus 70 plus 10 greater than 0. I hope there is no confusion on that. Now, if I could split the middle term, minus 5 and minus 2 works perfectly fine. So t square minus 5t minus 2t plus 10 is greater than 0. I hope it is understandable. Now, if I could split and factorize it, I'll say one of the factors is going to be t minus 5 and the other factor is going to be, if I take minus 2 common, it will be t minus 5. So I'll take t minus 2 as the other factor and it is told to be positive. We know in quadratic we can directly generalize it that here I want this quadratic which had the coefficient of t square to be positive is needed to be greater than 0. We know it happens before the smaller root and after the greater root. Even if you use the Weaver method, the same conclusion can be drawn. So from here, I'll simply conclude that here, I'll say that t will be either less than the smaller root, which is 2, or t will be greater than the bigger root, which is 5. But that's not the answer to this question because the problem is t is not t is actually cot inverse x. Now, if you have remembered the graph of cot inverse x, you will get a lot of clarity from that graph. I'll show it to you so that you are able to deduce a lot of things. Do you remember this was the graph of cot inverse x? From minus infinity to infinity, it was there on the x-axis. But on the y-axis, it was from 0 to pi. A continuous function. I hope you can see it. A decreasing function. So if I could simply bring this graph here in front of you, you will be able to conclude a lot of things. How? And let me just simply try and help you with that here. Let's say this is the x-axis. I hope there is no confusion on that. This is here the y-axis. I hope that is also understood by you all. Now, if these are the x-axis and y-axis, of course, let me draw one more line, which is going to be a line parallel to the x-axis, which will be what's wrong here? Okay, so I possibly won't be able to rotate it because of this delete sign and them are overlapping here. Okay, so this is a line parallel to the x-axis. Now, I'll say this is 0 and this is pi. Of course, here it will be leading to minus infinity and this will be leading to plus infinity. So there is no doubt that the graph will look like this, right? This, of course, is the middle point, which is pi by 2 on the y-axis. Did you understand this particular part? I hope there is no confusion on it. Now, if I could simply try and tell you a lot of things based on this result, can you help me with the approximate value of pi? So the approximate value of pi is 3.14, as we all know it very clearly. Now, look at this particular part. When somebody says, I hope you remember this is the graph of cot inverse x. So if you are simply saying that this is the graph of y is equals to cot inverse x. So whatever I'm seeing on the y-axis are the values of cot inverse x. Whatever I'm seeing on the x-axis are the corresponding values of x for that cot inverse x. I hope there is no confusion on that. Now from that graph, I'll draw a lot of conclusions because as of now, we haven't discussed DOD, maxima and minima and a lot more things. So from graph, I'm trying to give you more clarity here. Now let's look at that. See, if somebody says t should be greater than 5, what are they trying to say? T means cot inverse x. So what they're wanting to have is that cot inverse x should be greater than 5. So, as we know that cot inverse x, the maximum value of cot inverse x is going to be pi. That too when x reaches minus infinity. So, I hope you're realizing we can have the maximum value of cot x to be 3.514, which is also a reaching value, which is what we are approaching. We are not attaining it. So, of course, cot inverse x greater than 5, it won't be true for any value of x. Did you get that part? It can never happen because the maximum value of cot inverse x as per the graph of cot inverse x is going to be pi, which is approximately 3.14. So when somebody says that find all the x for which cot inverse x is greater than 5, I'll say no such x exists because cot inverse x cannot go beyond 3.14, then it can never go beyond 5. So I'll say from here there is no x. There is no x for which this will be true. No solution for that front. So that part we have already discarded. But if I talk about this front, t less than 2, then can you help me with the approximate value of 2? See, if this is 3.14, this is approximately 1.57. So above 1.57, I'll be seeing a 2 here. So this is the value of 2. So let's say corresponding to 2, this is a point. This is a point. So this must be a point. So what can you say about this point? We say that this point here, this is 2, which is the value of cot inverse x. So if somebody says that 2 is the value of cot inverse x, 2 is the value of cot inverse x, what is going to be the value of x? The value of x is going to be cot 2. Did you get my point very clearly? I hope you're understanding it very clearly. There is no confusion on that. So here what I'm trying to say is that somebody is willing us to say that t should be less than 2. So I'll say yes, t should be less than 2. T means what? T means cot inverse x should be less than 2. But what I also know is that cot inverse x is less than 2, and of course it is not always less than 2. It is always greater than 0 as well, because it is the minimum value of cot inverse x is 0. That is also, it approaches when x approaches infinity. So I'll say cot inverse x lies between 0 to 2. 2 because as per this question it should be less than 2, and 0 because we know from the graph of cot inverse x the value of cot inverse x, the minimum value of cot inverse x can be 0. That is also what we achieve. That is open interval. We cannot include 0 here. Now, if I simply reach to certain conclusions, I'll say this is a decreasing function. Decreasing function means that 2 I'll be attaining at cot 2 and 0 I'll be attaining at infinity. So I hope you're realizing this is the portion of the graph which we are interested in. This is the portion of the graph which we are interested in. Why am I saying so? Because I am considering the values of cot inverse x from 0 to infinity. Sorry, 0 to 2. And corresponding to 0 to 2, if I look at the graph of cot inverse x, this is the portion we are now dealing with. This is the portion of the graph we are dealing with. So corresponding to these values, we are looking for the values on x-axis. So corresponding to these values, the values on the x-axis will be these. I hope you can see it. And these values begin with cot 2 and it reaches till infinity. I hope there is no doubt on that. So if I were to define the values of x, I'll say that x starts from cot 2, and it reaches till infinity. This is going to be the values of x. So x should be between cot 2 to infinity. That is what we are given in the open interval in the option B. Were you able to digest this entire question clearly? It looked like a quadratic inequality Wavy curve method, but then there came the graph of cot inverse x. And this can be done or understood only when you know these inverse functions, when you know their graphs, when you have understood them more clearly. So if you don't know this particular front, you won't be able to conclude this particular answer. This is something which most of you can do, but something which is tricky or unique here is this part. And I hope you have gotten a great clarity on that front. Now, moving ahead towards the next concept here, let's now start discussing the properties. I'll be sharing their proofs as well, but not all. I'll be giving you the direct formula, and of course, I'll be telling you the logics behind them. Do remember that these are the properties which are very minute in nature. They come up with certain conditions, and there you are supposed to remember those conditions. You may say that in the real examination hall, we may derive these conclusions based on the conditions given in the question. Don't rely on that. They are heavy in terms of derivations, in terms of proof. So you cannot derive them. It will end up consuming a lot of time. So here, if you want to master ITF, the way we are insisting you that you should remember the learning, you remember the identities which we have discussed in the chapter trigonometric functions. In the same fashion here as well, you need to learn these identities and their variants. For example, here, if I say what is the value of sine inverse of sine theta? So it is theta, but not always. That's a problem. A lot of students say that, sir, it is a function, it is inverse of it. So inverse of a function nullifies it and you're left with theta. That is true. But this theta cannot be any real value. In that case, the theta should be from minus pi by 2 to pi by 2 only. So whenever you have theta from minus 90 degree to 90 degree only, then only you say that sine inverse of sine theta is theta. I hope you're realizing that and you will remember that. Similarly, when we talk about cos inverse of cos theta, what was the principal value of cos inverse theta we have taken, cos inverse x we have taken? I hope you remember, from 0 to pi. So if theta is between 0 to pi, then only cos inverse of cos theta will be theta. Similarly, I hope you must have remembered now or understood now that tan inverse of tan theta will be theta if theta is between minus pi by 2 to pi by 2. On the basis of this, can you not predict the 3 more conclusions? I hope you must have remembered that here also we can say that cosec inverse of cosec theta will be theta, but theta should be from minus pi by 2 to pi by 2 closed interval, and it should not be 0. Similarly, when you talk about sec inverse of sec theta, principal value 0 to pi closed interval, but theta cannot be pi by 2, then it will be theta. Similarly, when you talk about cot inverse of cot theta, it can also be theta, but for that theta should be from 0 to pi open interval. So if you're fulfilling these criterion, then only you will be saying criteria, then only you will be saying that f inverse of f of x will be x as far as trigonometric functions are considered. Do you remember that? This is not always true. Remember it. Usually students in a rush, replace it, that whenever they are asked, let's say sine inverse of sine theta, they end up replacing it by theta, but they forget that theta should be between those values. And that's where they commit the errors and they mark the wrong answers. I'll show it. I'll demonstrate it with a question, of course. Don't worry about that. So I need to ensure that whenever I'm nullifying this inverse by this function, I need to ensure that this theta lies between its principal range, which we have discussed for inverse functions. Will you remember that? I'll try to give you more clarity. These graphs we can understand more clearly. I'll come back to these graphs and try and make you understand them. Before that, I'll take an example. I'll take a question, and through that, I'll give you more clarity. Then I'll come back to these graphs. So don't worry about that. All of this will be discussing. But first of all, let's take a question. Through this question, I'll be in a better position to make you understand that. How? Please have a look at that. Let's forget this question asked by JEE Mains in 2025. Let's look at this option only. Sine inverse of sine 5. This is what we are trying to work out upon. Sine inverse of sine 5. Now, if I ask you what could be the value of sine inverse of sine 5, a student who does not know the concept of inverse trigonometric functions may end up saying that the answer should be 5, and that's wrong. What did we discuss? We have discussed that what we had discussed is that here sine inverse of sine theta, yes, is theta, but for that theta should lie between minus pi by 2 to pi by 2. I hope you haven't forgotten that. Now, check this value 5. Is it between minus pi by 2 to pi by 2? If you don't understand this particular front, please understand pi is always 3.14. If pi is 3.14, pi by 2 is 1.57. So if I'm saying minus pi by 2 to pi by 2, so I'm saying approximately from minus 1.57 to 1.57. So whenever you see the value of that angle in radian to be lying from minus 1.5 to 1.5 approximately, then you will end up cancelling or nullifying these, and then you write this value as it is. But here in this case, that is not the scenario. That is not happening. I hope you can see it directly here. What do? I think we have a very, very, very good advantageous part here. What is that? We can use the cyclicity, the periodicity of trigonometric functions, and by that I can create something which will help me in nullifying sine inverse by sine. So what are you saying? We are not able to understand this at all. What are you exactly saying? I am saying that do we know the periodicity? Do we know the cyclicity? What does it mean? Give me a multiple of pi. Give me a multiple of pi which is close to 5. So we know that pi is 3.14. So what will be the value of 2 pi? 2 pi is going to be, I hope there is no confusion on that, double of 3.14, which is somewhere around 6.28. Are you getting it? Are you getting it? And from 2 pi, if I'm subtracting 5, if from 2 pi, if I subtract 5, what do I get? So from 2 pi, if I subtract 5, I'm just talking about an approximate value. So from 6.28, if I'm subtracting 5, I'm getting an approximate value of 1.28. I hope we are going right. Yes, 6.28 minus 5 is going to be 1.28. Now, why am I doing all this? Just have patience and watch. This 1.28, does it lie between minus 1.5 and 1.57? Yes. This 1.28 is less than this. So it lies between this particular range. Why are you doing all this, sir? We are not able to get this at all. Now look at this part. Look at this particular part. Let us say I write here sine 2 pi minus 5. Then what wrong am I doing here by saying so? What is the problem here? So if I write sine 2 pi minus 5, sir, if you know that if I try to find sine 2 pi minus 5, you will say 2 pi. Where does 2 pi lie? So it lies on the positive x-axis. And from 2 pi, if I'm subtracting some angle, it should be lying in the fourth quadrant. This is how you can see it directly. Don't go for the value 5 here. So in the fourth quadrant, we all know that sine is negative. But because of 2 pi, ratio wouldn't change. So I'll write it as minus sine 5. I'll write it minus sine 5, which means I'll say that sine 5 can be written as minus of sine 2 pi minus 5. Can I say so? Why are you doing all this, sir? We are not able to get this front. Okay, forget this. But at this stage, Are you comfortable or convinced with the fact that sine 5 can be written as negative of sine 2 pi minus 5? Do you all agree with that? Okay, so let me do that here. If I replace the value of sine 5 here, can I not say the question now looks like sine inverse of negative of sine of 2 pi minus 5? I hope you are comfortably understanding this. So whatever this value is, we already had this discussion that sine inverse x is an odd function. Do you remember that? We had a discussion about that. The sine inverse x is an odd function. And if it is an odd function, we also had a discussion that sine inverse of minus x can be written as minus of sine inverse x because sine inverse x is an odd function. So if it is an odd function, can I not use this property here? Sine inverse of negative of something. So this negative sign can be taken outside. So now I can write it as negative of sine inverse of sine of 2 pi minus 5. Now here comes the interesting part. What do you mean by that? I am trying to make you understand a very interesting part here. Look at the value 2 pi minus 5. The 2 pi minus 5 is a value which is 1.28, which lies between minus pi by 2 to pi by 2. So this value over here lies between minus pi by 2 to pi by 2. And if this value lies between minus pi by 2 to pi by 2, then will I not say sine inverse of sine theta is theta? This is exactly what we have discussed. So here I can write it as theta, which is 2 pi minus 5. And before that a negative sign there. So negative of 2 pi minus 5. And if I multiply this negative side inside, I'll get pi 5 minus 2 pi. That's the value. That's the value here. So sine inverse of sine 5 is nothing but 5 minus 2 pi. Did you get that result? Did you understand this? Of course, this is something which you won't be doing. This is something which I have written very exhaustively, very comprehensively to make you understand this concept, to make you understand all the details. But here I hope you're able to understand that how are we deducing all this. Similarly, let us talk about this result, cos inverse of cos 5. What can I say about this? Okay, so let's talk about this result as well. So cos inverse of cos 5, right? Before I could say or conclude something about this, let me make you realize something which we have discussed. Do you remember we had a discussion on this, that cos inverse of cos theta will be theta as long as this theta is between 0 to pi. Do you remember? Sine, cosine, sine, tan and cosec minus pi by 2 to pi by 2. But when it comes to cos, sec and cot, 0 to pi. Of course, some changes are there, but something related to this only will happen. So here, if I'm talking about cos inverse of cos theta, it will be theta as long as theta is between 0 to pi. What does it mean? This clearly means that the value, the approximate value, if I could give you some approximation, it should be from 0 to 3.14. Approximation, I'm saying. Now, if I get back to the discussion we are having, here what is 5? Sir, 5 is greater than 3.14. So that wouldn't do justice here. But again, if I go back to the discussion, that here I can use the cyclicity, I can use the periodicity. So if I could use that, do we not know that, can you say something about 2 pi minus 5? Again 2 pi minus 5, yes, because a multiple of pi which is closest to 5 will be 2 pi, and that will give me the smallest difference, and through that I can ensure it will lie between 0 to pi. Did you get my intent, my motive? So with that, I'll say 2 pi minus 5 is what I'll be using here. So with that, if I simply ask you the approximate value of 2 pi minus 5, you will say 2 pi 6.28. 6.28 minus 5 is approximately 1.28. And does 1.28 lie between this? Yes, it does. It clearly does. 1.28 is between 0 to 3.14. So that does our job. So here, I'll be writing it as cos inverse of cos of 5. Okay, forget it right now. Let me begin with this part. Can you help me with the value of cos 2 pi minus 5? Again, if I help you with this quadrant theory, we are again in the fourth quadrant, 2 pi minus theta, fourth quadrant, and in the fourth quadrant, cos is positive. And of course, because of 2 pi, the ratio wouldn't change. So I'll be writing it as cos 5. This is what we know. So I'll use the inverse, which means I'll replace cos 5 by this value. So my question becomes cos inverse of cos 5 I am replacing by cos of 2 pi minus 5. Did you get this part? Any confusion on that? Along with this, what you should notice, understand here is this front, that here, I hope you are not getting confused with the fact that 2 pi minus 5 is 1.28 approximately, which is between this. And if theta lies between 0 to pi, I can replace cos inverse cos theta by theta. So cos inverse of cos theta, where theta is between 0 to pi, can be replaced by theta, which is 2 pi minus 5. So this is the value of cos inverse of cos of 5, which is 2 pi minus 5. Are you all understanding? Cos inverse of cos 5 cannot be just 5. You have to pay a lot of attention here, and you have to make some more arrangements here. So I think I have received the values here. I know the value of A and I know the value of B. So what is A here? If I could find A was 5 minus 2 pi. What was A? A was 5 minus 2 pi. And what was B, students? I think I can make comment on B as well. B was 2 pi minus 5. B was 2 pi minus 5. I think if I know A and B, I can find sum of A square and B square. That is something easy, which you all can also do and mark the correct option. But here, the challenging and the tricky part was understanding how do you deal with this 5 in the context of sine inverse and cos inverse. Did you get that part? I hope there is no confusion on that. And if you have understood this front, I think understanding these graphs and all of this will be simple and easy now, because you just simply define them in their own ranges and then domains. So don't learn all these graphs, don't learn all these formulae. I have tried making you understand it through this particular approach, And if you remember this approach, you need not look at those graphs, you need not remember those graphs at all. Please understand that. So skip those graphs. They are not to be learnt. If you have remembered what we have discussed in the previous question. Did you get that part? Can we move ahead? Now, let's talk about something else. What is that else? This particular part. Previously, we have discussed sine inverse of sine x. This time, I'm saying sine of sine inverse x. So is there a catch again? Yes. Previously, when I was dealing with sine inverse of sine theta, that was an angle. Here, when I'm dealing with sine of sine inverse x, this x is a value. I hope you are understanding this. So I cannot write, I hope you're remembering, the catch here is this, that let's say, although they won't give a question like this, but let's say somebody asks you that what is the value of sine inverse of 2? Then you will say that this problem cannot be solved. Why? Because 2 does not lie in the domain of sine inverse x. Sine inverse x has a domain from -1 to 1 only. So if somebody says that sine of sine inverse is 2, that is wrong. That is absolutely wrong. Why is it wrong? Because here, if you are paying attention to this part, x should lie between -1 to 1. Whenever you are willing to say that sine of sine inverse x is x. So again, the inverse of sine inverse x is sine. So you cannot say that they can nullify each other and you will get x. First of all, you need to ensure that it lies in its domain. So whenever you are willing to write sine of sine inverse x as x, then you should have this thing here that x should lie between -1 and 1. And here you cannot use the periodicity the way we have used previously. Sine inverse of sine theta is theta. Whenever theta is between minus pi by 2 to pi by 2. Even if theta was not between minus pi by 2 to pi by 2, we can use cyclicity or periodicity and we can bring it between minus pi by 2 to pi by 2. But here, you cannot do it. Sine inverse x is not a periodic function. It is a 1, 1 onto function. And that's where, if you are willing to write something here, if you are willing to nullify sine inverse by sine, then you should have this x from -1 to 1 only. I hope you remember, sine and cos both are going to be same. Cos also will say that cos of cos inverse x will be x as long as x is from -1 to 1. Similarly, tan and cot, they'll also say the same thing. I hope you can see that cot of cot inverse x and tan of tan inverse x is x as long as x is a real number. That is the liberty you have for tan and cot. But again, when you talk about these two other functions, sec and cosec, then of course we remember cosec inverse x and sec inverse x are defined for all the values except for the values between -1 and 1. So that again needs to be remembered by you, that cosec of cosec inverse x and sec of sec inverse x can be called x, but x should not take any value between -1 and 1 open interval. Did you get that part? I hope there is no confusion on that. You will remember it. And if you will remember it, let me show you the graphs as well. And these graphs you can remember and you should remember because they'll help you more. You should be very easily be able to generalize that, yes, this is exactly what is going to happen. Why? Because now look at this particular part. When you say that, sir, sine of sine inverse x or cos of cos inverse x is going to be x as long as x is between -1 to 1. So when x is between -1 to 1, y is also going to be between -1 to 1. So will I not say that, yes, here it is clearly a straight line y is equals to x, but the domain and range is from -1 to 1 only. Do you get that part? So the graph will be a straight line y is equals to x, but from -1 to 1. That is something very easily should be understood by you all. But when you talk about tan of tan inverse x or cot of cot inverse x, where we know that x can be any real number, that will still behave as x only, because y is equals to x will what happen here. So this will be a straight line from, of course, minus infinity to infinity on the both axes, x-axis and y-axis. But the challenge here is that students miss this particular catch or part, that it is not the same or true or same case for cosec of cosec inverse x or sec of sec inverse x, because this is x as long as mod x is greater than 1 or equal to 1, which means x should be either less than minus 1 or greater than 1. Equal is also there. So which means I'll again see a straight line y is equals to x, but its existence won't be there between minus 1 and 1. Did you get that part? So I hope all the three graphs are very easily understood by you all. Now, that's the part where you should pay more attention to. Of course, we'll discuss their proofs, but at this stage, you should start noticing that these results should be memorized by you. These results should be there at your fingertips. With practice, of course, you can bring them at your fingertips, but you should have these results with you, because we'll be using these results a lot at a lot of places. So this is the first result we have here. The first result says that here, if I'm having sine inverse of minus x, as we have already used this result, I hope you remember it, can be stated as minus sine inverse x, because sine inverse x is an odd function. This can be proved through some other conclusions as well, but I think this is sufficient. And that will be true. I think there is something wrong here. For tan inverse also, it should be a negative sign here. So even in tan inverse of minus x, I can write it as minus tan inverse x. And the same I'll be doing for cosec as well. So here as well, for cosec inverse of minus x, I'll be writing it as minus of cosec inverse x. As I have already told you, sine, tan and cosec will fall under a category, and cos, cot and sec will fall under a different category. So if you look at cos inverse of minus x, it will not be minus cos inverse x. It will be pi minus cos inverse. I'll prove it, don't worry. But similarly here also, if you look at this particular part, which part? Sec inverse of minus x. I hope you can see it very clearly. Sec inverse of minus x is also pi minus sec inverse x. And similarly, cot inverse of minus x is also pi minus cot inverse. And also, don't forget that this is not always true. This comes with this constraint that if you are writing sine inverse of minus x as minus of sine inverse x, then yes, x will be between minus 1 and 1. The same will be true for cos inverse x as well. For tan and cot, I'll say x can be any real number. I hope you remember, for tan and cot, we can say x can be any real number. And for sec and cosec, don't forget, we are constantly time and again repeating this part, that x should be, mod x should be greater than equal to 1, as you can see it here. Did you get that part? What I'm trying to make you understand is, let's take any of the cases. I'll not be proving all the six. I'll just give you a demonstration for one. Let's say this one I'll choose. So here, can you help me with, let's say, cos pi minus x? What is the value of cos pi minus x, students? We all know pi is basically where? It lies on the negative x-axis. Pi minus x will push you in the second quadrant. In the second quadrant, what will happen? In the second quadrant, cos is negative. So I'll write it as minus of cos x, because of this pi, the ratio wouldn't change. So here I'll be saying minus of cos x. Now, so what is the advantage of this? Why did you do all this? So from that only, I'll establish the base for this particular result. What do I mean by that? From here, let's say cos inverse of minus x. What do we have here? Cos inverse of minus x, right? I hope this particular result you won't forget. And if I wish to write it differently so that you don't get confused with this x, let's say I'm writing it as cos pi minus theta. So we know that it is always minus cos theta. This is something you'll remember. Don't worry about that. You won't bother about that. I hope you'll remember it. Now, let me talk about this result here. Cos inverse of minus x. So let's say cos inverse of minus x, I'm replacing by, let's say, an angle alpha here. All right, I can do that. I can say so, because cos inverse of minus x will be a certain angle for all the values of x which are between minus 1 and 1. It will have a value alpha here, which will be between minus pi by 2 to pi by 2. Sorry, 0 to pi, because here it is cos inverse. I hope there's no confusion on that. Now, if I talk about cos inverse of minus x, please understand the catch here is this, that here I am now trying to make you understand that if cos inverse of minus x is alpha, by using this property, since it is already there between minus 1 to 1, can I say that cos alpha will be minus x? I hope there is no doubt or no confusion on that. So on the basis of it, can I not say that x will be minus cos alpha? Did you understand this part? I hope there is no confusion on that. I can do that, and we all know that this can be done. Now, we know minus of cos alpha can be written as cos pi minus alpha. Can I say so? So x I am writing as cos of pi minus alpha. X we have written as cos of pi minus alpha. Did you get that part? Now, if I'm writing, or if I'm able to write x as cos of pi minus alpha, from here, can I not say that if I take cos inverse on both sides, I'll be having cos inverse of x as cos inverse and cos are nullified because pi minus alpha will also fall under that same range 0 to pi. So from that, cos inverse of cos pi minus alpha can be written as pi minus alpha. I hope you're getting this part here clearly. Cos inverse of cos of pi minus alpha will be pi minus alpha because pi minus alpha will lie between 0 to pi. That same property which we have just discussed in the last slide. Now, going back to the discussion we are having, if I take alpha on the other side, cos inverse x on the other side, alpha will be pi minus cos inverse x. What was alpha, students? Alpha was cos inverse of minus x. I think this is exactly what we have been able to prove. In the same fashion, you can prove all the other results as well. Don't worry or bother about that. The only thing you need to remember is sine inverse, tan inverse, and cosec inverse will fall under one category. Cos inverse, cot inverse, and sec inverse will fall under another category most of the times. Even in this formula as well, if I look at sine inverse of minus x, tan inverse of minus x, and cosec inverse of minus x, they behaved like an odd function. They are actually odd functions. But when you talk about cos inverse of minus x, cot inverse of minus x, and sec inverse of minus x, they'll be written as pi minus inverse of that function times x, inverse of that function of x. Did you get that part? I hope there is no confusion on that. Now, if you have gotten clarity on that front, let me, this is of course the proof which we have already discussed, so I think we need not discuss that part, but yes, this is another property that we need to discuss here. Here, sine inverse of 1 by x can be written as cosec inverse x. Here you need to understand that x should be between minus 1 to 1. Sorry, x should be less than minus 1 and greater than 1. Here you'll have a closed interval. Let me make that correction. This should be a closed interval. Now, what am I trying to say here is a very simple phenomena. Let me check whether we have the proof or not. Yes, we do have a proof. Let's say I take cosec inverse x as theta. So when I'm taking cosec inverse x as theta, I can say that x will be cosec theta because x is under that range. So I can directly say that cosec theta will be x. I hope you can follow that result. And if cosec theta is x, their reciprocals can also be taken. So the reciprocal of x will be 1 by x. The reciprocal of cosec theta will be sine theta. Now, please remember, I'll go back to the discussion we were having. We have taken x from minus infinity to minus 1 and 1 to infinity. That means 1 by x will be from minus 1 to 1. 1 by x will be from minus 1 to 1. Of course, I have to exclude 0 from here. I hope you're getting it. So, if 1 by x is from minus 1 to 1, excluding 0, in that case, will you not say that, sir, if it is from minus 1 to 1, excluding 0, I can take its inverse there, which means theta can be written as sine inverse of 1 by x. From here, I hope there is no confusion in writing this particular result. Did you get that part? What does it mean? It means that theta, which was cosec inverse x, can now be written as sine inverse of 1 by x. In the same fashion, we can say or talk about some more results and conclusions as well. Like cos inverse of 1 by x can be taken as sec inverse x. But again, it should fall under that category of domain. What does it mean? That if I'm writing cos inverse of 1 by x, that 1 by x, I hope you remember very clearly that it should lie between minus 1 and 1. And of course, when you say that cos inverse of 1 by x, that 1 by x should lie between minus 1 and 1, that means x should be this. Of course, 1 by x can never be 0. So even if this 1 by x is between minus 1 and 1, it will never be 0 for any value of x. But here what you need to understand is that this domain should match here. That domain should never be violated. I hope you are understanding the logic here. I'll try and make you understand this particular result as well. Here you need to be more cautious. Tan inverse of 1 by x. Now, this kind of operations I'll keep doing, and I'm explaining this logic here, which I won't be, explaining further every time. Sometimes I'll do it, but most of the times I'll give you results like this. And the result, the reason, the explanation I'm giving you here is very simple. That here, look at this part. Usually, without any hesitation, you will say tan inverse 1 by x should be cot inverse x, as long as x is a real number. But that's a catch. That's a problem. Here, what is the problem? Please understand. I'll draw the graph of tan inverse x and cot inverse x both, through which I'll try to make you understand this particular result. See, we know the graph of tan inverse x. The graph of tan inverse x goes like this. Of course, this is the graph of tan inverse x look like. And if I draw the graph of cot inverse x, it looks like this. Do you remember that? Now, I'll give you some more clarity on some more fronts. I hope you remember that graph of tan inverse x on the y-axis lies between minus pi by 2 to pi by 2. But graph of cot inverse x lies between 0 to pi on the y-axis. Do you remember that? This clearly is the graph of tan inverse x here. I hope you understand this. And this is the graph of cot inverse x here. Now, why am I discussing all this? The problem here is, please understand, the catch here is this, that here, when you are finding the value of tan inverse 1 by x, tan inverse 1 by x. So, whenever x is positive, tan inverse 1 by x, then 1 by x will also be positive. So, whenever x is positive, 1 by x also is going to be positive. And whenever you take tan inverse of a positive value, whenever you take tan inverse of a positive value, you get 0 to pi by 2. You get the values from 0 to pi by 2. I hope you're getting it. I hope you're perfectly okay and fine with this. Now, I am saying tan inverse 1 by x is x. I'm trying to match the domains here. So here also, when I'm taking all the positive values, that is from 0 to infinity, they are giving me all the values from 0 to pi by 2. So I think that is matching. So here also, whenever I'm taking all the positive values, I'm getting all the values from 0 to pi by 2. Here also, if I'm taking all the positive values from 0 to infinity, I'm taking all the values from 0 to pi by 2. So that is fine. That is in sync. But to bring the other part in sync, the problem is here. What is the problem? Here, when you take the values of x which are negative, which is from minus infinity to 0, tan inverse x gives you values from minus pi by 2 to 0. But when you talk about cot inverse x and you take all the negative values, that is from minus infinity to 0, cot inverse x gives you the values from pi by 2 to pi. So to bring them in sync, because of course, if I could write it as only cot inverse x, it will be giving me values from pi by 2 to pi. But on the left hand side, this is giving me the values from 0 to minus pi by 2 to 0. So how is it possible? Can you find any value between minus pi by 2 to 0 which is equal to pi by 2 to pi? No, of course we cannot, and that's a problem. So to have a sync here, I'll add minus pi here. As of now, I'm not giving the complete proof. I'm just giving you a direct proof here. Through graphs, I'm just giving you the idea or the hint that at this stage, what you all must understand is that here, tan inverse 1 by x, tan inverse 1 by x for the negative values of x, 1 by x will also be negative. So tan inverse 1 by x, tan inverse of something negative will be from minus pi by 2 to 0. But if I not look at this part, if I simply look at this part, then the problem arises here that cot inverse x for the negative values of x. Of course, if x is negative, x will be negative and 1 by x is also going to be negative. So in that case, if I'm taking the negative values in cot inverse x, I'll be getting values from pi by 2 to pi, and that's a problem. So this is giving me values from pi by 2 to pi. This is giving me values from minus pi by 2 to 0. So how is it equal? So to bring equality here, I have added minus pi to it. And the moment you add minus pi to it, its domain, its principal range, its principal value gets adjusted. Now look at this part. This part was already very well adjusted. It was also giving me values from 0 to pi by 2. This was also giving me values from 0 to pi by 2 for all the values of x which were positive. But the moment x got negative, the issue arose. So when the issue was there, I simply fixed it by adding a minus pi to it. So the moment you add minus pi to the values from pi by 2 to pi, you will have, I repeat, if I'll just try to make you understand this, that cot inverse x, look at this part, cot inverse x for all the values of x which are negative will lie between pi by 2 to pi. Do you get that part? Will lie between all the values from pi by 2 to pi. Did you get that part? Now look at this. If I'm subtracting pi from all the three sides, so pi by 2 minus pi will be minus pi by 2. This will be minus pi plus cot inverse x. And here, pi minus pi will be 0. And that's exactly what I was trying to say. Minus pi plus cot inverse x is equal to tan inverse 1 by x. So tan inverse 1 by x for the values of x which are negative, I'll be writing it as minus pi plus cot inverse x. Because then only I'll have it from minus pi by 2 to 0. Because for the negative values of x, 1 by x also is going to be negative, and for that tan inverse 1 by x will give me values from minus pi by 2 to 0. So to adjust that, to have that in sync, the left hand side and the right hand side, to make them equal, I need to ensure that the RHS also gives me the same range of principal values, which is also minus pi by 2 to 0, which will happen if I could add minus pi to it. To derive such conclusions, this is the method, this is the technique I use. Although there is a standard derivation or a proof as well, which again will go a little longer. This, of course, may have taken a lot of time because this is something which I have explained to you for the first time. But if you start noticing this kind of pattern, if you start following this kind of logic, you will also develop these formulae with a lot of ease. This is not a right approach. This is not the appropriate approach. There is a standard formula and derivation. But yes, the derivations are lengthy in nature. And if you wish to derive such formula, if you wish to verify these formulae, you can use this hit and trial or cross-check method. Did you get this part? I hope you are understanding. For sine inverse 1 by x and cos inverse 1 by x, I could write them as cosec inverse x and sec inverse x respectively, as long as they were in the domain. Tan inverse x also, or tan inverse 1 by x also, will be true for all the real values of x. But here there is a catch that whenever x is positive, I won't hesitate in writing tan inverse 1 by x as cot inverse x. But if x is negative, don't straight away write it as cot inverse x. That's a problem. You can write it as cot inverse x, but add minus pi to it. That's a problem. Otherwise, you will get a value which is between pi by 2 to pi. But 10 would say that tan inverse don't accept any values from pi by 2 to pi because it ends at pi by 2, because it lies between minus pi by 2 to pi by 2. So how can you have both of them to be equal in that case? And that's the verification or validation I'm trying to give you here. Did you understand that part? I hope you are getting a complete clarity that from now on, I'll keep bringing such adjustments to keep the left hand side and right hand side in sync with their principal value. Did you get that part? Shall I move ahead? Okay. So now if I could go to the next part here, these are the proofs as we have already discussed them. And then these are some more properties. Can you believe this? Once in, maybe I don't remember the year, but in a year, IIT JEE has directly asked this particular as a question. What they did was, I don't remember the year exactly, but what they did was they asked the values of sine inverse x plus cos inverse x. And everybody marked pi by 2. Option D said none of these. Why? Because they did not say that x is between minus 1 to 1. So a lot of us actually get confused with this fact that we always are in a rush to mark sine inverse x plus cos inverse x as pi by 2. No, that is not always true. Please understand, it will be pi by 2 as long as x is between minus 1 and 1. I hope you're understanding that. That is the first primary condition which you should fulfill. If it does not hold true, how can you have the existence of sine inverse x and cos inverse x? Let's say if I ask you sine inverse 5, I hope you're realizing, plus cos inverse 5, then you won't say pi by 2, because this 5 is not lying between minus 1 and 1, because for 5 sine inverse doesn't exist at all. Sine inverse holds true or exists for the values of x which are between minus 1 and 1. So how can you have sine inverse 5 even defined? And if it is not even defined, then how can you say that this is pi by 2? Are you understanding this simple fact here? Did you get my point very clearly? Shall I go ahead or move ahead with this part? Now, if I move ahead from this particular part, let me tell you these particular results as well. Of course, the proof we'll discuss, but let's discuss the result. Tan inverse x plus cot inverse x is also pi by 2, but this is true for all the real numbers. Sec inverse x plus cosec inverse x is also pi by 2, but this is true for this range. So I hope remember, sin and cos, the range is minus 1 to 1. Tan and cot, the range is all the real numbers. Range means the values of x here. Range means, I hope, principal value range I'm mentioning or talking about. And for sec inverse x and cosec inverse x, the values of x will be between minus infinity to minus 1 and 1 to infinity, where minus 1 and 1 are included. So this is something which is true. The proof is really simple, students. You will all must agree that yes, we know that sine 90 minus theta is cos theta. So on the basis of this only we can conclude this result. So I hope you remember that cos and sine in terms of angles are complementary in nature. Did you understand my statement here? I'll try and make you understand this very clearly here, that here, if I call it x for a while, then would you not say that yes, theta can be said cos inverse x? I hope you remember this part. And here, pi by 2 minus theta can also be taken as pi by 2 minus theta can also be taken as sine inverse x. And if I replace the value of this theta by cos inverse x, and if I take it on the other side, I'll have pi by 2 is equal to sine inverse x plus cos inverse x. And by using this particular result only, will I not be able to conclude the other two results? But are you not realizing, yes, the condition is if sine and cos return me the values between -1 and 1. So when I'm taking the inverse sine inverse x and cos inverse x, then this x must lie between -1 and 1. So you should stay aware of these things. If these things are not there in your mind while solving the questions, then you are committing some errors. Did you get that part? Even while solving the questions, I'll demonstrate these errors to you. But of course, I'm believing that when time and again I'm asking you to stay cautious, stay alert, I hope you are understanding these learnings. That these are not the only results which you should remember. But along with these results, you should remember these conditions. ITF is useless if you don't remember these results. ITF is absolutely useless if you don't remember these results. So you may say that tan inverse x plus cot inverse x is pi by 2, but you should remember it is true for all the real values of x. You may say that sec inverse x plus cosec inverse x is pi by 2, but you should remember that it is true whenever mod x is greater than equal to 1. Did you get these three results? I hope you'll remember them. Now, if you have understood it, let us move ahead towards the next set of properties. This is the proof as we have already discussed. Here comes another question, an interesting one, a brilliant one, a really amazing one. How? JEE Mains in 2025 has asked it. I'll again ask you that you pause the screen right now, look at the question and try doing it by yourself. It again uses the concept of simple, I would say the concept which we have just discussed in the last slide, along with a concept which is related to the maxima and minima of quadratic, which we have discussed in the first lecture. So if you have remembered these two things, you will be able to solve this question in one go, in one attempt only. Try doing it, and then we'll discuss this question together, right? First of all, what you must be realizing that there I can establish a relationship between sec inverse x and cosec inverse x. Do you all agree on this? Because it says using the principal value. So I need not bother about its domain now. This is what they have already told you. Even if they don't tell you, this is what you should assume, that this is all going to deal with the principal values only. Now, inverse trigonometric function is the sum of the maximum and the minimum values. So technically its maximum and minima is needed to be found. Now how do we do it? So either aim greater than equal to gm can be used or some other thing can be used. So let's try and use that. First of all, as we have just discussed, sec inverse x plus cosec inverse x is going to be pi by 2. And I need not bother about its domain because it is already mentioned in the domain. That question follows the domain. Yeah. So what I know is that since I know that the result is sec inverse x plus, of course it is inverse, so don't get confused with that. Cosec inverse x is pi by 2, right? So either of these I'll replace. So let's say I'm replacing cosec inverse x. So I'm replacing cosec inverse x by cosec inverse x, I'm replacing by pi by 2 minus sec inverse x. Can I do so? Can I do that? I hope that doesn't create any problem here. It is perfectly visible. Great. Now, with that, I am making one more assumption that let's say sec inverse x is t for a while. So I'm replacing sec inverse x by t. So that is also what I'm assuming. I hope you don't get confused by that. So now the question looks like 16 times. I think it is whole of. Yes, it is whole of. 16 times whole of sec inverse square. So square of sec inverse, which means t square. So this is t square plus, what do we have next? Cosec inverse x, which I'm replacing by pi by 2 minus sec inverse x. And we can write pi by 2 minus sec inverse x as pi by 2 minus t whole square. This is what we are dealing with. Can I not deal with this quadratic? Let's simplify this first so that we can create some conclusions and generalizations on this. Now, if I could simply begin with this, what we have here in this, I'll say 16 times. This is t square. I'll get a t square from here. So t square plus t square will be, t square plus t square will be 2 times t square. Did you get that? Now, what else I'll be getting is pi by 2 whole raised to the power 2, which is going to be pi square by 4, which I'll write later. Along with this, I'll get one more result, 2 into pi by 2 into t with a negative sign. So 2 into are getting cancelled. So I'm left with minus pi t. So minus pi t plus, what is the next part? That is, I think, pi square by 4. So I have opened this square and I have gotten this result. I hope you all are comfortable with that. Now let's talk about this quadratic. We know how to find the maxima and minima of a quadratic, but with a constraint that, don't forget, it's not a quadratic in t, rather it's a quadratic in sec inverse x. So the variable here is not t. The variable here is sec inverse x. Don't forget that. Now, why am I saying this? Because either I can use the completion converting into a perfect square, then I can think it or look at this, or I could use some other methods as well, like drawing the parabola, drawing the graph or the curve, and then I could look at it. Or the third method, using AOD, application of derivatives, maxima and minima. I could do all, but let's use the first method, which says that let's convert it into a perfect square, because when I convert it to a perfect square, I need to bring one more factor into picture, which says that sec inverse x is actually the value of t. It's not just t. So I cannot randomly take any value of t. I should take t, which allows me to have sec inverse x range. I'll talk about that later. But let me first of all convert it into a perfect square. So when I do that, what do I have? 16, right? Let me take this 2 common from here. When I take this 2 common from here, I get 32 outside. So you have two choices. Either you push this 16 inside, which I think will unnecessarily complicate it, or may smooth it, make it more simpler and easy. Whatever it does, so let me think what is more better. Pushing this 16 inside or taking this 2 common. Both are fine, I think. Both are absolutely fine. So let me push 8 inside. So I'll write this 16 as 8 into 2, and I'm pushing 8 inside, because that will eliminate this 4 from here. That might help us a little. So I'm taking 8 from this 16, so I'm left with 2 outside. And when I push 8 inside, 8 into 2 is 16, so that gives me 16 t squared. That is fine, great. When I push this 8 here, it is 8 pi t. Okay, I'll write it as 8 pi t. That is also fine. And here, when you have pushed 8 here, so 8 by 4 is 2. So that is what? 2 pi square. Okay. Okay. Whatever advantage we have gotten or received by doing that, let's explore that feature now. Now, I hope there is nothing wrong with this part. You have understood this front very clearly, that out of 16, I have taken this 8. So 8 into 2 is 16. 8 pi t is here, and 8 by 4 is 2 pi square. I hope you're comfortably understanding this. Now, here, if I keep this 2 as it is, but now if I wish to convert it into a perfect square, a square plus b square minus 2ab or something like that, let me have a look at that possibility. So 16t square, can I write it as 4t whole square? I hope there is nothing wrong in that. So 16t square I have written as 4t square. I hope you are perfectly okay with that. Now, the next result is 2 pi square. Okay, we have this 2 pi square, that's fine. But what I need to notice here is that how do I break this 8 pi t into? Okay, so now let me try to look at this 8 pi t. So first of all, 8 pi t is what we are dealing with, right? So 8 pi t, let me just show it to you here. 8 pi t, if I write it as minus 2, this minus there, this 8 I have written as 2. Then I'm writing 4t from here. I'm taking 4t from here. And then I'm taking this pi here. Do you not think minus 2 into 40 into pi can also be written as minus 8 pi t only? Because this is minus 8 pi t only. Sir, why did you do this? And why are we actually doing it? Are you not making it more complicated? Trust me, I am actually simplifying it. How? Please understand. First of all, why did I do it? See, this became a square. Now there should be some b square, which I'll work upon later. But if I'm looking at 8 pi t, it is minus 2ab, because this is a 4t. So I could directly got a greater clarity on b, which is going to be pi only. So if this is 4t square, I could break minus 8 pi t into minus 2 into 40 into pi. I'll write it like this only so that you don't get confused. So I'm writing minus 8 pi t as minus 2 into 4t into pi. I hope there is no confusion on that. I can break minus 8 pi t as minus 2 into 40 into pi. Okay with that? So a square minus 2ab. So what does b look like? B is pi in that case. So I should have a pi square from here. So 2 pi square, can I not write as pi square plus pi square? Why did you do that? Now please understand, look at this particular result. Look at this part only. Look at just this part, this front. Does it not look like a square plus b square minus 2ab? I could convert it into a perfect square. Why am I doing all this? You will have this sense in the next step, but let me do it at this stage now. So when you do it, it is 2 outside. Then a square plus b square minus 2b is a minus b whole square. So what do we have? We have 4t minus pi whole square plus pi square, and this whole expression is needed to be doubled. That is the value of our expression where I've written sec inverse x as t. Okay, so I'll begin my conclusion now with some other generalizations. Forget this. This is our question, but in a different form. Now, why did I do it? In the upcoming next few steps, you will get more clarity about this. Now, let me begin my discussion with t. I could not use application of derivatives or simply the maxima minima of quadratic because the problem was it was not just a quadratic in t. It had a variable t. It was a quadratic in t, but t was actually sec inverse x. Now let me talk about t now. What is t? T is sec inverse x. Yes, t is sec inverse x. So we know that sec inverse x, which is t in our case, lies between which values? We know that it lies between 0 to pi. Do you remember that? We had a discussion on sec inverse x. We know that t lies between 0 to pi. If you have forgotten it, I hope you remember it. The function sec inverse x lies between 0 to pi. If you have forgotten it, I'll show the graph again to you. I'll go back to this particular slide where we had a discussion on sec inverse x. Let me just show this graph so that you get a great and complete and perfect clarity on sec inverse x. I think this is the graph of sec inverse x. Yes. So I hope you know that sec inverse x lies between 0 to pi when it comes to talk about its range, and it does not include pi by 2. Do you remember that? As we have already discussed. So what I know is that t lies between 0 to pi where it does not include pi. So if I get back to our discussion, which we are having right now in this question, I know t lies between 0 to pi and it does not include a value, which is what? Which is pi by 2. So it lies between 0 to pi and it does not include a value, which is pi by 2. Right? So here, let me write it like this, that t is between 0 to pi by 2 and then from pi by 2 to pi. I hope there is no confusion or doubt or hesitation on that. And of course, we know 0 and pi are included. Did you get that? Now, why did I do that? Or why am I saying so? Because now if you look at this expression, this is 4t minus pi whole square, right? Now, let's not worry about the 0 for a while. And as of now, I remember that pi by 2 is not included in that case. If I club this data, I'm writing t as lying from 0 to pi, where I am explicitly remembering that t cannot take a value which is pi by 2. So I'll remember this as a result. But what I know is that t is going to take the values from 0 to pi, all the values excluding one value, which I have skipped, which I'll take care of later on. So what I know is that t takes all the values from 0 to pi because it will help me in finding its maxima and minima, the maxima and minima of the expression which I'm trying to figure out. Now, can you say something about 4t? Yes, we can. So what is going to be the value of 4t? Yes, from here I can say the value of 4t is going to be, I need to multiply both the sides by 4. So 4t, it will give you 4 pi and it will give you 4 into 0 is 0. I hope you are comfortably understanding it. I have multiplied all the sides by 4. This is something you can generalize by yourself as well through your intuition. But at this stage, I'm giving you more clarity through a very basic approach. 4t minus pi. So now I need to have a minus pi. So I'm subtracting pi from all the three sides. So it is minus pi, then it is 4t minus pi, and this is 4 pi minus pi, which is 3 pi. Are you getting this part very clearly, students? Now what do we have next? I need to square it. Okay, so if I'm squaring it, now please understand, this is a value which lies between a negative value and a positive value. So when you see that, let's say, let me take an example here to make you understand this more clearly. Let me just take an example, right? Let's say x takes the values from minus 2 to 4. So what can you say about x square? I hope you won't say that it will take values from 4 to 16. That's wrong. Imagine all the numbers from minus 2 to 4, and when you square them, the minimum value which you'll get will be 0 and the maximum which you'll get will be the square of the value which is greater in magnitude. So between minus 2 and 4, greater is 4. So square is going to be 16, although it cannot be attained because there is no equality sign here. Did you get that part? Now same logic if I could use here, magnitude wise 3 pi is greater. So square of 4t minus pi, this will lie between 3 pi and pi. Magnitude wise 3 pi is greater. So this will be less than 9 pi square. It will have its minimum value to be 0. Did you understand this front? I hope there is no confusion on it. From this particular part, now if I go back to this, I need to add pi square to it. I'm just trying to create that expression over here. So if I add pi square on the both sides, it will be 4t minus pi whole square plus of course pi square is what I'm doing, and this will lie between. If I have added pi square on both these sides, what I'm having is pi square here, and 9 pi square plus pi square is 10 pi square. I hope you are able to understand this. To 4d minus pi whole square, I have added pi square because this is what I'm trying to build. I hope you are having the end result in mind. Now what I'm having next is, I'll multiply both the sides by 2. All the three sides by 2. So when you multiply all the three sides by 2, in the middle you have 2 times whole of 4t minus pi whole square plus pi square. And when you multiply both the sides by 2, it is going to be 2 pi square, and this is going to be 20 pi square. Now let's bring this consideration picture. I think pi by 2 wouldn't matter at all, because this all was being decided based on 0 and pi, which t can attain. And if t could attain 0 and pi, this expression could attain this as minima and this as maxima. This expression had nothing to do with pi by 2. Pi by 2 is somewhere in between, and its maxima and minima got decided with the help of these points, because sec inverse x is a strictly decreasing function. On the basis of that, you can always conclude at its maximum value. At its maximum value, I'll have minima, and its minimum value, I'll have maxima. I hope you understand the concept of functions which are strictly decreasing. If you didn't understand that concept, which will explore in AOD, look at this particular part through which I have very from scratch only, I have tried making you understand this particular result. Now, what is it? This is our question. This is exactly what our question is, right? I hope you remember the expression which we are given in the question. So if I could simply comment on its minimum and maximum value, this is the maximum value of our question, and this here is the minimum value of our question or expression what we are asked. So what are we asked? We are asked the sum of the maximum and minimum value of this expression, which is nothing but what? 20 pi square and 2 pi square. So 20 pi square plus 2 pi is 22 pi square. Did you understand this part? I hope there is no confusion on it. You are able to understand that how did we deal with quadratic? Then from quadratic, how can we simply not take its maximum minima just like that? We should take care of the inverse trigonometric functions, their ranges, their curvature, their nature, and a lot more. So the better clarity, the better understanding you have of these concepts, the better you will be able to deal with these category of questions, right? Now, if I could move ahead with the next set of properties, here we'll talk about some next properties. This concept is a very simple concept. If you have remembered the learning which we have discussed in the chapter trigonometric functions, which concepts I'm talking about? Let's say if I'm talking about, or if I'm asking you about the formula 10 of alpha plus beta, what do you say? You know that it is 10 alpha plus 10 beta whole divided by 1 minus 10 alpha 10 beta. Do you remember this result? Do you remember this as a result? That same result can be used in a different sense when I say that, let's say 10 alpha is equal to x and 10 beta is equal to y. When I have it, I hope I won't hesitate in saying that alpha is 10 inverse x, beta is 10 inverse y. From here, can I not say that 10 of alpha plus beta? Let's say 10 of alpha plus beta can be said as 10 alpha, which is x, 10 beta, which is y, upon 1 minus 10 alpha beta, which is 1 minus xy. Of course, I can take 10 inverse. So alpha plus beta, which is going to be alpha is 10 inverse x. I hope you can relate it from here. And beta is going to be 10 inverse y. So alpha plus beta, which is 10 inverse x plus 10 inverse y, is equal to 10 inverse of x plus y divided by 1 minus xy. But it is not as easy as I have created it. I have taken a lot of liberties. What do I mean by taking a lot of liberties? When I say that I have taken a lot of liberties, that means that I did not take care of a lot of values. I did not take care of its, principal ranges. Because here, I could simply understand everything in this manner, that yes, everything is falling as per my choice, as per my, desired or favorable result. What I'm trying to say here is that, let's say the problem here is that if x plus y and 1 upon x, 1 minus xy, x plus y upon 1 minus xy, here, if let's say by chance, if this result gives me a value which does not fall in sync with the value which the LHS has to offer. Are you understanding my point? In that case, I just cannot say that this is going to be equal to this. Again, I hope you remember we had a discussion on 10 inverse 1 by x. It will not always be cot inverse x. It will be cot inverse x as long as x is positive. but it will be minus pi plus cot inverse x if x is negative. The same problem will now start arising now. And in this one shot, I won't be able to prove you all these results, all these conclusions or properties of formulae. So here, I'll be giving you these formulae with this simple mindset that to make those adjustments with their principal range or principal value, I have to do certain arrangements. We'll talk about these arrangements and these conclusions, but you should remember that this is something which you got to learn. Let's have a look at this particular part. So whenever xy is less than 1, whenever the product of xy is less than 1, whatever value tan inverse x plus tan inverse y offers, that value will lie under this range which tan inverse of x plus y upon 1 minus xy offers. So I need not add or subtract anything. But in case if both x and y are positive and xy is greater than 1, if both xy are positive and xy, the product is greater than 1, in that case, this is going to be negative. In that case, if this is going to lie between 0 to pi by 2, rather 0 to pi by 2, 0 to pi by 2, if effectively their sum will be between 0 to pi. So here to bring it between 0 to pi, where it will be negative now, I need to add pi to it. I hope you're understanding this conclusion here very clearly. So I have to make some adjustments. For example, whenever x and y both are negative, but still if xy is greater than 1, in that case, I'll add minus pi to it. So whenever I have the liberty to choose, if no variable, no data, no clarity is given, I won't hesitate in saying that tan inverse x plus tan inverse y, I'll directly replace by tan inverse of x plus y upon 1 minus xy. But if I have some clarity, if I get some more input on x and y, then I'll be more specific and I'll use the right variant. I'll keep the LHS and RHS in sync. So along with this formula, we remember this as this, you should remember the other two versions as well. Are you getting my point very clearly? Not just that, this will be true for other formulae as well. What do I mean by that? Here, in tan inverse x minus tan inverse y, this will be same only. This will be same only. But here also there is a problem. What is that problem? The problem is tan inverse of x minus y upon 1 plus xy. It can be said directly whenever xy is greater than minus 1. But again, if you have these cases that both x and y, where x is greater than 0, y is less than 0, and xy is less than minus 1, then you got to add pi to it. If x is negative, y is positive, and xy is less than minus 1, in that case, you got to add minus pi to it. You need to be more cautious. Trust me, you need not remember this formula. What I am saying is, remember this version only. Sir, why are you saying this? Because if somebody says that find the formula for tan inverse x minus tan inverse y, then I'll say use the property of tan inverse being odd. What do I mean by that? Then use the property of tan inverse x plus tan inverse y, but instead of y, use minus y here. So as per the condition, you can apply the case and then you'll find the answer. But in that case also, you'll have to remember all the three variants of this formula. Did you get that part? So even if you don't remember tan inverse x minus tan inverse y, you could use these properties only. I hope you're understanding the point here. Now, moving ahead towards the next case here. This is the generalized version. Again, I hope you remember for that formula, if I could simply give you this clarity. Do you remember we had a discussion that we discussed or talked about tan alpha plus beta plus gamma, tan of whole of alpha plus beta plus gamma. We had a discussion that we wrote it as tan alpha plus tan beta plus tan gamma, which I'm writing as summation of tan alpha minus S1, I hope you remember, minus S3. What is S3? Tan alpha into tan beta into tan gamma. So which is written as summation 3 at a time, which is tan alpha, tan beta, and tan gamma. Do you remember that? Tan gamma, I'm really sorry. This is tan gamma. Give me a second, students. Similarly, in the denominator, you write S0. S0 is 1 minus S2. What is S2? Tan alpha, tan beta, plus tan beta, tan gamma, plus tan gamma, tan alpha, which I am writing as summation tan alpha, tan beta. Of course, plus S4 would appear next, but S4 wouldn't exist because there are only 3 angles. From this formula only, we have derived this result. So here, remember, tan inverse x1 plus tan inverse x2 until tan inverse xn will be written as tan inverse of whole of S1 minus S3 plus S5 minus S7, all the odd ones in the numerator, divided by 1 minus S2 plus S4 minus S6 plus S8 minus S10, and all the even ones in the denominator. But what do they represent? S1, S3, S5? Sk denotes the sum of the product of x1, x2, xn taking k at a time. For example, if I'm talking about S1, what does S1 say? Sum of x1, x2, x3, S4, 1 at a time. Let's say, what do I mean by S3? S3 means sum of 3 at a time. So x1, x2, x3, x1, x2, x4, like these pairs, triplets of 3. And then there's sum. What do you mean by S2? S2 means sum of 2 at a time. x1, x2, then x2, x3, then x1, x4, all the two twos, any pair of all the two. And then you take the sum of it. So I hope you're able to generalize or understand this particular conclusion. I hope you'll remember it the way we have discussed in trigonometry. That same formula is getting extended here. So I hope it doesn't confuse you at all. Now, if I move ahead and give you more clarity on this particular formula, we'll seek help from this particular question. This will give you a complete, a greater and extensive clarity on this particular formula which we'll be using here. So this question uses two concepts. Which two concepts? First one, where of course we'll be using the property of tan inverse x minus tan inverse y. And the second one, where we'll be bringing the consideration of the concept telescoping sum, the special series, where we have discussed the VN method. I hope you must have remembered it. We have discussed in trigonometric function sequence and series. That's exactly what we are bringing again here in picture. How? Let me try and rewrite this question again. 2 to 3 concepts are going to be used. One concept of sigma rule, the summation rule, finding the general term and then finding the summation or generalizing the term. The method of difference I'll be using. Along with that, after that, I'll bring the inverse trigonometric formula into picture, tan inverse x minus tan inverse y, and then I'll be using VN method telescopic sum. So 3 to formulae are going to be used in this one single question. So a good question, a very good question, an excellent question, which will give you a very holistic, very comprehensive and very thorough clarity on this particular concept. So this single question is going to give you a lot of clarity. So I'm hoping that you all are still here watching this with utmost focus and attention. And yes, if you feel confident, do try it. I'll be really happy if some of you could do it. And of course, do write in the comment box if you're able to do it. And whatever method you use, don't hesitate in writing that. We'll love to hear it from you. That what method, what approach did you use? So this is an infinite series and its sum is needed to be found. How do we do it? Okay. Let me first of all, try to write it in a different form. So the different form will say, sir, the question can look like tan inverse of 4 by 7 plus tan inverse of 4 by 19 plus tan inverse of 4 by 39 plus tan inverse of 4 by 67. Tell me honestly, how many of you are able to get this part, that we can do it? I hope you remember cot inverse of x can be written as tan inverse 1 by x, reciprocal of x, as long as x is positive. But if it was negative, I am supposed to use minus pi to it. But that is not happening over here in this case. That is also what you do is when tan inverse x is needed to be written as cot inverse 1 by x. Then you add minus pi to cot inverse 1 by x. I hope you remember it. If x is negative. But here, since x is positive, I can take directly the reciprocal. And most of the times, they use the direct formula only, the straightforward ones. Very rarely, very seldom they use the other versions of the formulae. But you should remember all the formulae, all the variants. So here, I hope you remember cot inverse x can be written as tan inverse 1 by x as long as x is positive, and that's exactly what we have done over here. Now, so still it is unfigurable. We cannot solve this question. How do we do it? Okay. Let me try and find a pattern here with 7, 19, 39 and 67. If I could crack that, I might be able to solve this question, right? So I am skipping this question as of now and I'm trying to work upon these numbers. So 7, 19, 39 and 67, okay? So we have the numbers 7, then the next number is 19, 39, 19 and then 39, and then what do we have next? Then we have 67, right? And they should have given us some more numbers so that we could verify it, but still we'll go with this part only so that we start solving it. So here, can you help me with the difference between 7 and 19? I'll say to generalize it, let's try and use method of difference. So method of difference, what does it say? So sir, if the difference has a pattern, either an AP or a GP, then I'll be able to generalize the nth term, and by that I can write or generalize the nth term of that sequence. How do we do it? Let's learn that. So here 7, 19, 39 and 67. The difference between 19 and 7, I hope I need not tell you, 9 minus 7 is 2, so it is 12. Are you comfortable with that? Here. The difference between 19 and 39, I hope you know, is 20. Great. The difference between 39 and 67, so it is, let's say 40 for a while. This is 68 for a while. I've moved one step ahead, both of them. So 68 and 40 is basically 28. So the difference will be 28. If you don't understand this, you can subtract 39 from 67. What I've done is, whatever difference is there between 39 and 67, that same difference will be there between 40 and 68. So that logic I have used here. Now, 12, 20 and 28. So there is no logic here. There is no pattern. There is a pattern. If you pay attention, there is a very good pattern, because 12 and 20 have a difference of 8. 20 and 28 have a difference of 8. So there is a pattern. There is indeed a pattern. How do we solve this category of questions? In sequence and series, we have discussed method of difference. That method of differences we'll use here. So how do we use that? First of all, I have seen the pattern that the numbers are constant. The difference is constant. So the difference is constant. It means the difference of these consecutive terms is an AP, 19, 20, 28. If that difference of difference is constant, this means this is an AP, which means this can be generalized. So how do we do that? I'll use the method of difference. So here, 7, 19, 39 and 67. I hope, how did I verify that? That part is very well understood by you all. So I have the number 7, then I'll write plus 19, then the next number I'll write as 39, and then the next number is 67, and so on. Let's say that's how I'll be having the nth term, 7, 19, 39 and 67. And I write this sum as S. So this is a standard predefined method which I'll be using. This same S I'll write again, but with one step, ahead. With this 7 shifted to the next step. So this 7 I'll write here, this 19 I'll write here, this 39 I'll write here. In the same fashion, the second last term will appear here, and this Tn will move to the next further step. I hope there is no confusion on that. And from the first step or the first equation, I'll subtract the second equation. I hope we can do that. There is no hesitation in that. So when you do that, what result do you get? I hope there is no hesitation. S minus S is going to be 0. 7 minus 0 is going to be 7. 19 minus 7, as we have discussed, is 12. 39 minus 19 was 20. And this was 28, and so on until this term. Plus Tn, but 0 minus Tn will be minus Tn. So this is minus Tn. If I could simply ask you how many terms are here. So if I could ask you here, there are total n terms. First term, second term, third term, fourth term, n terms. So these terms, these are how many terms? They are total n terms. I hope there is no confusion on that. Now, if I bring this minus Tn on the left hand side, I'll have my plus Tn is equal to 7 plus 12 plus 20 plus 28 and so on. And these are total n terms. 7 doesn't fall into that category, but 12, 20, 28, they are forming an AP. I repeat, they are forming an AP. Which terms, students? These terms over here. So from 12 to these terms, they are forming an AP. So total number of terms were n. If I could include 7, till this last term, they were total n terms. But if I have excluded 7, these n minus 1 terms, these n minus 1 terms are in AP. I hope you're able to get this part. I hope there's no confusion on this front and you're able to digest whatever I'm saying so far. So if I could write Tn, then how will I write Tn as? I'll write Tn as 7 plus. Can you help me with this sum of n minus 1 terms of an AP? There is a shortcut as well, but for that shortcut, you have to remember different formula for different cases. And I don't want to confuse you at this stage. Method of differences has a substitute. If you Google it, you will find it. But at this stage, it is absolutely futile to use that. So let's learn that standard method. So what is that method? It says sum of n minus 1 terms of this AP. It is given by n by 2, which is n minus 1 in this case. So n minus 1 by 2 whole times 2a. 2a is 12 into 2, which is 24, plus n minus 1, which is n minus 1 minus 1. So n minus 2 times d. What is common difference? The common difference is 8. So it is into 8. That's the version we are having. So if I could simplify this, I think I'll be able to crack the nth term. So I am writing the nth term here as close as possible to my result. So if I push this 2 inside, I'm writing it here. I hope you don't mind that. So 7 plus n minus 1 times, what do I have here? 12 plus n minus 2 whole times 4, right? So it is 12 plus 4 times n minus 2. So 4 times n minus 2 is 4n minus 8. I hope you are comfortable with that. I am writing that result. The next step from there to here. So it is 7 plus. It is 7 plus n minus 1 times. What do I have next? It is 12 plus 4n minus 8. 4n remains 4n. 12 minus 8 is going to be 4. So it is 4n plus 4. It is going to be 4n plus 4. So it is going to be 4n plus 4. And this 4 I'm taking outside. I hope you're comfortably understanding it. So n plus 1, n minus 1 is n square minus 1, a plus b, a minus b, a square minus b square. So this result I'm writing here as 7 times 4 times whole of n square minus 1. So it is 4n square minus 4. So the result finally turns out as 4n square plus 3. 4n square plus 3. So nth term is given by 4n square plus 3. The best part here is that you had the sequence. You can verify it. Let's replace n by 1. So 4 plus 3 is 7. I have a 7. Let's replace n by 2. So 4 into 4, 16 plus 3, that is 19. We have 19. So that is generalized. The nth term is generalized. Once you are able to generalize the nth term, you can now say a lot about this because Tn is 4n square plus 3. The denominators are of the category 4n square plus 3. So if I wish to write its general term, if I wish to write this sequence, which I'm denoting by, let's say, any sign, can I write its general term as summation of 10 inverse of, the numerator is always 4. So let's write that 4 in the numerator. The denominator is now generalized as 4n square plus 3. So this is written as 4n square plus 3. Are you understanding this part comfortably? Here, so far, we are now done with method of differences. Now the VN method comes into picture. So can you believe this? This question had both. Along with those two, from sequence and series, they have now merged with the concept of trigonometric functions, inverse trigonometric functions, which is basically going to club with VN method. How? Let's have a look at that. So here, I'll be using this particular result. What does it say? I'm taking 4 common from both the sides, numerator and denominator. Why am I doing it? You will understand it in the next 2 steps. Have patience. So when I take 4 common, I hope you are not confused with n. I'm starting the value of n as 1 from the beginning and it is an infinite series. So n reaches till infinity. So summation will have n from 1 to infinity. I hope you're okay with that. From here, if I have taken 4 common, so I'll have summation. I'm not writing n 1 to infinity time and again. I'll do it in the end. If I take 4 common, it is summation 10 inverse. The numerator will have 1 and the denominator will have 4 is common. So n square plus this is 3 by 4. I hope you are understanding this comfortably. There is no confusion or doubt or hesitation on that. Now, what do I do next? To convert it into the formula for telescopic sum, I'm going to do something which will be understood by you in the next 2 steps, and that intuition you'll also build when you start solving questions based on it. So I'll try to have that formula 10 inverse of x minus y upon 1 plus xy. If I could create something like that, the job is done. I repeat, I'm trying to have the formula 10 inverse of x minus y upon 1 plus xy, which is 10 inverse x minus 10 inverse y. Do you remember that? Now, how do I use this? Please have a look at that. The numerator I'll sort later, but let me talk about the denominator first. So this looks like n square. Let's say I subtract and add 1 to it from the numerator. In the denominator, let me say that this is what? N square plus 3 by 4, right? So if I'm subtracting 1, then of course I need to add 1. So this is minus 1 plus 3 by 4 plus 1. I hope that I can do. So in the denominator, no major changes are done. I have subtracted 1 and added 1. Sir, how are you able to think like this? Trust me, with some practice and time, you will also be able to think like this. That formula I have in mind and I'm trying to create that. And that with some practice, you will also be able to think like that. How? Because if in the denominator I have written something like this, let me keep the numerator as it is. But when you do so, you have created something very great, very intelligent. Why? Because it says it is summation of 10 inverse of this expression. Now look at the denominator. See, this one I keep aside. So this is 1. Now what am I left with? N square minus 1 plus 3 by 4. So 1 minus 3 by 4 is minus 1 by 4 because minus 1 is negative, 3 by 4 is positive. Yes, it is minus 1 by 4. So it is plus n square minus 1 by 4. Can I write 1 by 4 is 1 by 2 whole square? And the numerator is 1 only. Now comes that part which will help you in understanding why am I doing all this. And you will also realize that yes, this is what is needed to be done and this much effort are supposed to be applied whenever dealing with the questions based on ITF. So, especially VN method, infinite series. Now, look at this part. That denominator 1 plus n square minus half square, can I write this as a plus b and a minus b? So n plus 1 by 2 and n minus 1 by 2. So this looks like summation of n inverse of denominator has 1 itself as here, n square minus 1 by 2 whole square. I'm writing as n plus 1 by 2 and n minus 1 by 2. I hope you are understanding this. The product of these two factors will become n square minus 1 by 4, which is exactly what we have in the denominator. So what is the advantage of this? Now comes the part which will help you in understanding this. From this, if I subtract this, I repeat, from n plus 1 by 2, if I subtract n minus 1 by 2, what do I get? I hope you can see n minus n, it is cancelled, and 1 by 2, 1 by 2 plus 1 by 2 is 1. So the numerator is still intact. What is the advantage of this? Now I'll come to the part which will help you in understanding that yes, there is indeed a very good advantage here, because we know that tan inverse x minus tan inverse y is actually tan inverse of whole of x minus y upon 1 plus xy, and that is what I have tried doing here. Did you get that part? This is why we were doing all this. And if we have done or created something like this, I think we have this formula right there in front of us. Summation, forget for a while, tan inverse of x minus y upon 1 plus xy. Can I not write it as summation of tan inverse x? What is x here? X is n plus 1 by 2. And what is y here? What is y? Y is n minus 1 by 2. So it should be minus tan inverse n minus 1 by 2. Did you get that? And here we know that n is from 1 to infinity. That is what you are supposed to do with the summation sign. So summation where n is from 1 to infinity. I hope there is no confusion on that. Now start putting different values of n. Now you'll start seeing the VN method getting applied. How? Have a look at that. See, I'll put value of n is 1. So when n is 1, it is tan inverse 1 plus 1 by 2, which is clearly nothing but what? 3 by 2. When I put 1 here, it is tan inverse 1 minus 1 by 2, which is tan inverse 1 by 2. Plus, when I replace this by 2, it is plus tan inverse 2 plus 1 by 2, which is clearly 5 by 2. And here 2 minus 1 by 2, which is 3 by 2. Have you started noticing VN getting applied? I hope most of you must have seen the pattern. And finally, when you reach till the end, the last step will be tan inverse. Let me write in terms of n only. Tan inverse n plus 1 by 2 only. I'll put n approaches infinity so that you don't get confused. And this is tan inverse n minus 1 by 2. And here, of course, we know that on this expression, this n is going till the last step till infinity. I hope you are comfortably understanding this result. Now let me move ahead with my conclusion here. Do you not realize, or do you not understand, or are you not seeing that, sir, here this tan inverse 3 by 2 is getting cancelled by tan inverse 3 by 2. Tan inverse 5 by 2 will also get cancelled. So all these terms will get cancelled except for this term and this term. That is exactly what we have discussed as a concept of VN method. Now, if I write these two terms, what do I get? Sir, I get limit n approaching infinity on this, which is tan inverse n plus 1 by 2 minus this, which is tan inverse 1 by 2. We know tan inverse infinity is pi by 2 because at pi by 2 it approaches infinity. So this is pi by 2 minus tan inverse 1 by 2. More than answer, what is important here is that how did I get it? How did I get it? Two things, methods of differences, and then second, VN method. And third, the formula tan inverse x minus tan inverse y. Tell me honestly, how many of you did get this answer correctly? More importantly, did you use the right method? Were you using the correct method? I hope this one single question, which was of course an extensive one, an lengthy one, as per your understanding of ITF so far, but still it must have given you a lot of clarity on this particular concept. The same set of formulae we will be seeing in the context of sine and cos as well, right? So instead of proving these results right now, I'll directly demonstrate that how can they be proved. For example, if you look at x as sine theta and y as cos theta, are you not seeing as sine theta cos theta plus, sorry, let's say x I'm taking as sine alpha, y I'm taking as, let's say, sine beta. So I hope you're understanding 1 minus sine square beta will be cos beta. So sine alpha cos beta plus cos alpha sine beta. What is it? It is sine alpha plus beta. And sine inverse of sine alpha plus beta will leave you with alpha plus beta, which are sine inverse x and sine inverse y. So I hope you're realizing the way we have proved tan inverse of x plus tan inverse y, which as tan inverse of x plus y upon 1 minus xy. In the same fashion, these also can be brought into picture. But this is a standard result. This one, the first one, is of course a standard result that sine a plus b is sine a cos b plus cos a sine b. That exactly is what is happening over here if you pay attention from the context of trigonometric functions. But what you need to understand is that it has its own variants. Of course, this will be the standard result as long as I have x and y between minus 1 and 1, and the sum of their squares to be less than 1. Their product should be negative, which means either of them should be negative, the other one should be positive. And see, either this and this should happen, or this and this should happen. Otherwise, in the other two cases, this is what you must have with you. For example, here, if x and y both are between 0 and 1, and if their sum of their squares is greater than 1, then this pi minus is needed to be done. And if they are between -1 and 0 and the sum of their squares is greater than 1, then minus pi minus this is needed to be done. So these are some variants which you need to remember. Of course, usually or mostly in the questions will end up using this result only. But I will still insist and ask you that don't forget these two conclusions as well. They are also going to be really useful and helpful, because you need to take care of a lot of things while dealing with questions on ITF. Yeah. Now, if I could move to the next result, I again would say don't remember it, don't learn it. If you remember the previous one, this can be concluded on the basis of previous one only, because sine inverse x is also an odd function. Here, look at this particular result. Cos a plus b. You know, cos of whole of a plus b is cos a cos b minus sin a sin b. In the same fashion, look at this part. Cos inverse of x plus cos inverse y. Are you realizing it? Xy, cos inverse of xy minus under root 1 minus x square and root 1 minus y square. I hope you're realizing. If I treat x, again, if I wish to prove it, I can, but in a simple result, I hope you remember, this can be proved by that simple identity only. So as of now, once we have already learnt with the proof of tan inverse of x plus tan inverse y, I think I can skip these and directly give the conclusions. Even if you forget in the real examination hall, you can seek help from the standard identities which we have learnt in trigonometric functions, and all of these can be derived. All the trigonometric formulae, all the multiple angle formulae, all the half angle formulae, they can be brought here in this sense as well. But with ITF, a lot more constraints come into picture, and you need to take care of those constraints. Similarly here as well, if I go ahead with the next part, cos inverse x minus cos inverse y, there you have this identity, and all of this will consolidate with one more example. So let's look at this particular result. How do we apply it? Let's first of all understand it. What does it say? Inverse trigonometric functions, they are assuming principal values only. X and y are two real numbers between -1 and 1. They are supposed to be, because cos inverse of x and sin inverse of y are being taken in the question. So they lie between -1 and 1 only. Although they have already told you that they are taking the principal values only. And then we are also told that alpha is a value which is between minus pi by 2 to pi. Okay, we'll talk about that later. So there is alpha which is lying between minus pi by 2 to pi. Now what are we asked? The minimum value of this expression. Now, how do we use the formula or the identities which we have learned previously in the previous slides in this particular question? There you will get more clarity. Most of the times, the standard versions are applied. But of course, sometimes you got to learn the other special cases or specific cases as well. Look at this particular result. How do we use it? First of all, please understand, I need to either convert this into the other formula or this into the other formula, because I need to have both of them either sine in terms of sine inverse or in cos inverse. So whatever you wish to have. And how do we do that? See, the result is pretty simple. We know a very important conclusion. We know a very, very, very important conclusion which says that if I have sine inverse x, just give me a second, x plus cos inverse x, then I can write it as pi by 2 as long as x is between -1 to 1 closed interval. Do you remember that? Now, if you have this result, we can convert any one into the other one. For example, in this question, I have sine and cos both. I hope you can see this in this question. So I want both of them to be either in cos inverse or sine inverse. So let's convert it into sine inverse at this stage. So this cos inverse x, I hope I can write as pi by 2 minus sine inverse x. Do you all agree with this? I hope there is no confusion on that. Or even the other version could be that this sine inverse y can be written as pi by 2 minus cos inverse y. I hope you all must agree with that. So whichever result you wish to use can be used. So here, let me rewrite this question as, first of all, cos inverse x I'm keeping intact minus sine inverse y. Can I not write it as pi by 2 minus cos inverse y without any hesitation, which is given as alpha? Do you all agree with this? Now, with that, if I could proceed further, will I not say that, sir, this minus pi by 2 I take on the other side, and here I'm left with cos inverse x plus cos inverse y, which is equal to alpha plus pi by 2, because this is minus pi by 2 on the left hand side. Now, what you should again take as a benefit of doubt here in this case is that here, if I have to deal with cos inverse plus cos inverse y, cos inverse x plus cos inverse y, I won't bother about these results. I'll always use the standard result, the general result. Similarly, let's say if I'm talked or asked about cos inverse x minus cos inverse y, I won't bother about the other results or special cases. I'll write the general or the standard result only. Because these special conditions are not specified or given. So why should I bother about them? I should simply use this. And they can be adjusted later on as per the requirement of the question. I hope you're understanding the point here. So if I could simply know the standard, the basic ones here, what we have is cos inverse x plus cos inverse y, which is cos inverse of xy minus under root over 1 minus x square times under root over 1 minus y square. Do you remember that result? So if I'm using that result over here, what I see happening over here is cos inverse of xy, cos inverse of xy minus under root over 1 minus x square times whole of under root over 1 minus y square. Do you remember that? This is the formula. Of course, whenever there is a plus, there is a negative sign. Cos A plus B is cos A cos B. Cos A cos B minus sin A sin B. Are you understanding it? Equal to alpha plus pi by 2. I hope there is no confusion on that. Now, please understand, alpha is between minus pi by 2 to pi. Alpha is between minus pi by 2 to pi. So if alpha is between, let me try and give you more clarity over here. We are told that alpha is between what? Minus pi by 2 to pi. So if I add pi by 2 on all the three sides, what do I have? I have pi by 2 here, I have pi by 2 here, and I have pi by 2 here. I hope there is no confusion on that. Did you get that? So alpha plus pi by 2 will be between 0 to 0 to pi plus pi by 2, which is 3 pi by 2. I hope there is no confusion on that. I hope there is no confusion on that. So for all the values between 0 to 3 pi by 2, I think I won't hesitate in taking the cos ratio on both the sides. I can do that. I hope you are understanding and realizing very clearly there's no confusion or hesitation on that. So if I am taking cos ratio on both the sides, this will remain as it is, and there I'll have cos alpha plus pi by 2. So here I can write this result as xy minus under root over 1 minus x square times under root over 1 minus y square is equal to cos of alpha plus pi by 2, or I can write it as cos pi by 2 plus alpha. Did you all get that? I hope there is no confusion on that. Now, what I do next is, let me try and make you understand that what does it mean? Cos 90 plus theta. Because of 90, the ratio will change because 90 lies on the y-axis. 90 plus 90 lies on the positive y-axis. Plus means second quadrant. So in the second quadrant, cos is negative. So this will become minus cos alpha. Do you all agree with that? Do you all understand that? Now, here, this is going to be xy minus this. You need not write time and again. I'm just writing it because I'm a teacher. I need to write all the steps to make you all understand everything. But here, you can skip a lot of steps and you can directly write the results. But don't skip so much that, you may end up losing some data, or you may end up getting confused or making some silly errors. So be more systematic, be more clear. What I need to do is I need to create something like this, x square plus y square plus 2xy. So to have something like that, see, what I'm trying to do is I'm bringing cos alpha on the left hand side, I'm taking this on the other side. So here it will be xy plus cos alpha on the left hand side. On the right hand side, I'll have under root 1 minus x square times under root 1 minus y square. Did you understand that part? Now let me square both these sides. So if I'm squaring both these sides, what result do I get? So if I'm squaring both the sides, the result I'm going to get are going to be x square y square plus cos square alpha. I hope you're getting it. Plus 2xy cos alpha. I hope you're understanding it. A plus b whole square. There's no doubt on that. On the right hand side, when these terms are squared, the under root signs are removed. So I'm left with 1 minus x square times whole of 1 minus y square. So on the right hand side, you're left with this, right? Can I directly multiply this? I hope you're realizing 1 into 1 will be 1. Then I'll have minus x square, then I'll have minus y square, and then I'll have plus x square y square. So can I write that product directly here? So I'll have 1, then minus x square, then minus y square, plus, of course, an x square y square. Now, if I simply pay attention to what I've gotten here is that x square y square can be cancelled by this x square y square. I hope there's no confusion on that. So what I'm going to do next is, I'll push cos square alpha on the other side and I'll take this on the other side. So I'll have now x square plus y square on the left hand side plus 2xy cos alpha on the left hand side. I hope there is no doubt on that. What am I now left with? I am now left with here cos square alpha and this as 1. So this is going to be 1 minus cos square alpha without any hesitation, I can write as sine square alpha. Did you get that part? Any confusion on that? Now let me get back to this conclusion. Alpha. Alpha was between minus pi by 2 to pi. Even if you draw the graph of sine alpha, although that is sine square alpha, but still, if I were to make you, if I were to help you with the graph of this, then it begins with this and it reaches to this point. So this is the graph of sine alpha, if alpha is between minus pi by 2 to pi. I hope you're getting it. So for all the values between minus pi by 2 to pi, sine alpha takes all the values from minus 1 to 1. Sine alpha takes all the values from minus 1 to 1. But what are we now dealing with? We are now dealing with sine square alpha. So sine square alpha will take all the values from 0 to 1. Do you all agree with this on me? Because it is sine square alpha. Sine alpha was lying between minus 1 and 1. So its square will lie between 0 and 1. Now let me get back to this. We were asked the minimum value of this expression. X square plus y square plus 2xy. So there is a problem. We have gotten 2xy sine alpha is what we need to figure out, and this says 2xy cos alpha. So I think I needed to take the sine formula. So there is a problem. I should have used the sine formula here. So there is a problem. I did not notice it. I have mistakenly in a flow, got carried away and I took cos. So I think that's a problem. That's a problem. I should have noticed and taken care of it. But I think I have the approach now. What is the approach? The only change you need to bring in the question is, sir, I'll begin from here only. Instead of converting this sine, I'll convert this cos into sine. So I'll write this as pi by 2 minus sine inverse x. And when you do that, the entire question will get changed. So of course, we haven't wasted anything. What we have learned is that yes, this is not working, but yes, through this you must have learned that we have attained a result. Let's say in the question, had they asked you the minimum value of this expression, would you not be able to answer that yes, the answer would have been 0? So through that same idea, you can apply this particular logic. The approach has been told, although we haven't gotten the exact expression what we are told. But let's say, had the question been like this, although the option may not match, I'll just simply give you this idea that instead of sine alpha, let's say, had they given you a question that they are asking you the value of 2xy cos alpha. Let's say the question is x square plus y square plus 2xy cos alpha. In that case, would you not say x square plus y square plus 2xy cos alpha we have cracked as sine square alpha? And we know sine alpha is between minus 1 to 1. So sine square alpha lies between 0 to 1. So the minimum value of sine square alpha will be 0. And hence the minimum value of this expression will also be 0. Did you get that? Did you understand the whole question? So to that question, when it is changed into this, it will be 0. If it is sine alpha, what I'll do is, the only change I'll bring to my question is, I'll keep it as sine square x sine inverse x. How? Pi by 2 minus sine inverse x. And through that, I'll be using the same result and getting the same answer. Did you understand the whole process? Are you comfortably understanding what is needed to be done and how should you solve this category of questions? I hope you're getting or building a great clarity on this. Let's move to the next set of formulae or the properties. What is that? It says that whenever x is between 0 to 1, so I've ensured that x is positive and of course it is between 0 to 1, be more specific. We can write sine inverse x as cos inverse under root 1 minus x square. How do I personally remember it? See, we have ensured that x is between 0 and 1, right? So what you can do is you can say that, sir, sine inverse x, let's say we are treating as theta. X is between 0 and 1, so don't bother about anything else much. So we can say that theta is going to be, theta is already sine inverse x. So can I say that sine theta is going to be x? Can I say that sine theta is basically x upon 1? So I can take a right angled triangle which has theta as its angle, which can have a perpendicular, let's say, as x, and which can have a hypotenuse as 1 or proportional to x in 1. So similarly, on the basis of that, will I not say that its base is going to be hypotenuse square minus perpendicular square whole raised to the power 1 by 2, which means 100 over 1 minus x square. And after looking at this, I can conclude everything. What do I mean by that? I am trying to make you understand that what will you say about cos theta? You will say, sir, cos theta is going to be base upon hypotenuse. So cos theta will be under root 1 minus x square. That means theta will be cos inverse under root 1 minus x square. Did you get that? What can you say about tan theta? So tan theta will be perpendicular upon base. So theta will be tan inverse of x upon under root 1 minus x square. Are you getting this? And their reciprocals, which means if Sine inverse x is this, then it will be cos inverse 1 by x. If this is cos inverse of this, then it will be sec inverse of this, reciprocal of that. If this is tan inverse of this, then the same will be cot inverse of this upon this, reciprocal of it. Are you understanding how am I deriving these results? The only constant which you should keep in your mind is that x should be positive between 0 and 1. This is what you can do to predict or crack such questions. Similarly, there comes one more property, which is when x is between 0 to minus 1. There is a small correction here. Let me make that correction first of all here, that when x is between 0 to minus 1. So in that case, the small change here is this, that here, let's say if cos inverse x is what I'm beginning with. So if I'm beginning with cos inverse x, and let's say I'm calling it to be theta. So if x is between 0 to minus 1, I hope you remember the graph of cos inverse x will tell you a lot. So of course, I can say that cos theta is going to be x. And if I talk about x from 0 to minus 1, if I could tell you more clarity or give you more clarity about this, we know that from pi by 2 to pi is what we are dealing with, because if cos is between 0 to minus 1, oh, I'm really sorry. Yes, it should have been. I'm really sorry. It is from 0 to 1 only. Let me make that correction here. It is from 0 to 1 only. I'm really sorry. So even again, the previous formula was for when x was between 0 to 1. If sine inverse x is given as theta, I can convert these also. Similarly, let's say this time I'm given cos inverse x, but corresponding to cos inverse, the same sine, tan and cot, sec and cosec are needed. Will I not use the same logic? See, we have this x between 0 to 1. So if we have this x between 0 to 1, we know that cos inverse x is theta, let's say for a while, which means cos theta will be x. And on the basis of this, again, I'll create a right angle triangle, which will have theta as an angle. So corresponding to this theta, this is base upon hypotenuse. So base can be treated as x, hypotenuse can be treated as 1, which means perpendicular will be under root over 1 minus x square by using Pythagoras. I hope you all must agree with that. Or any value proportional to these values. On the basis of that, you can predict the other ratios, and correspondingly, the same corresponding theta value in terms of sine inverse, tan inverse, cot inverse, cosec inverse, and sec inverse can be found. The same logic which we have used with the previous property. Did you get that? On the basis of this, we can predict some more results. I hope that doesn't matter much, but more importantly, I think there is some correction here. It should not be cos inverse x, it should be tan inverse. So there is a small correction. It should have been tan inverse x. There it should have been tan inverse x. For example, if it is tan inverse, then of course tan inverse means perpendicular upon base. So x is perpendicular, base is 1. So hypotenuse is under root 1 plus x square, which means sine inverse will be perpendicular upon hypotenuse. Cos inverse will be base upon hypotenuse. So I hope you are understanding the results. And if I take their reciprocals, I can get the other inverse results as well. I hope you are able to conclude this even without writing that entire, drawing that entire right angle triangle and all stuff. You can conclude a lot of things directly from here. But for that, you need to have this x to be positive. I hope you're understanding all the conclusions and results, because I need to ensure that principal value of these inverse functions remain intact. They all fall under the same category. They stay in sync. So these conditions must not be forgotten by you. Remember that. These are some very special results which we have brought into picture. Now, do you remember that we have discussed some more formulae? For example, in Trigo, we have discussed that sine 2 theta is always 2 sine theta cos theta. 2 sine theta cos, what is wrong with this? 2 sine theta cos theta. So here, if I treat sine theta as x, we know cos theta will be under root 1 minus x square. So this is sine inverse 2 sine theta cos theta. I hope you remember this. And here it is basically 2 theta, which is this sine 2 theta. Because that sign I have brought here as sine inverse, if you are able to understand it like that only. Did you get my point? In the same fashion, do you remember that if that condition gets violated, if I want to keep everything in sync, I need to make some arrangements, and these are those arrangements only. So don't worry about that. My concern will be, I hope at least this formula you won't forget. You will remember at least this general result, which is derived from this standard formula only, which we have learnt in trigonometric functions. From that only, all these formulae can be generalized or derived. I hope you remember the formula for sine 3 theta, which was 3 sine theta minus 4 sine cube theta. That exactly is what happening over here. I hope no confusion on that. Similarly, if I could bring more formulae, for example, cos 2 theta. Do you remember 2 cos square theta minus 1? I hope there is no confusion on that. Similarly, if I could bring some more data, for example, cos 3 theta, what was it? It was 4 cos cube theta minus 3 cos theta. Are you seeing that resemblance over here? I hope there is no confusion on that. Similarly, when you talk about tan to theta, so we have discussed tan to theta and its other variants. What do I mean by that? We have had a discussion about that. Yes, tan to theta can be written as 2 tan theta upon 1 minus tan square theta. I hope you are able to derive these formulae. I am giving you the hint. I am just simply trying to tell you a very simple phenomena that the more well versed you are with the formula of trigonometric functions, the more ease you'll have while dealing with questions based on inverse trigonometric functions. Those formulae which we are discussing here are all derived from that chapter only. I hope you can see it directly getting used. I hope you remember tan 3 theta. What was tan 3 theta? 3 tan theta minus 10 cube theta upon 1 minus 3 tan square theta. Do you remember that? S1 minus S3 upon 1 minus S2. That exactly is what is happening over here. Now, if I could move ahead with the next set of rules, I am having a question right there in front of me. Let's try and solve this particular question. How do we do it? So the question says tan inverse y is equal to tan inverse x plus tan inverse 2x upon 1 minus x square, where mod x is less than 1 by root 3. That is something they have given to assist us. Why? Let me try and tell you. When somebody says that mod x is less than 1 by root 3, what does it mean? Are they not saying that x is between minus 1 by root 3 to 1 by root 3? If I take tan inverse on both sides, let's say if I take tan inverse on both sides, so what are they trying to give you? That C, tan inverse is an increasing function. So tan inverse of minus 1 by root 3, we know it happens at 30 degree. Tan 30 degrees 1 by root 3, tan is an odd function. So 1 by root 3 will be 30 degree and this will be minus 30 degree. 30 degree means what? Pi by 6. So tan inverse x will lie between minus pi by 6 to pi by 6. Did you get this result? That is the meaning of this which they have tried telling us. Now, what more advantages can be brought here? We know tan inverse of 2x upon 1 minus x square. Do you remember that 2 tan theta upon 1 minus tan square theta is tan 2 theta, which means this entire expression is nothing but what? 2 tan inverse x. So I can write tan inverse y is equals to tan inverse x plus 2 tan inverse x. Did you get that? Even if you use that direct result, tan inverse x plus tan inverse y here, tan inverse x plus tan inverse y, which is tan inverse of x plus y upon 1 minus xy, that can also be used, but I'm trying to keep it even simpler. How? Look at this. On the LHS, I'm having tan inverse y, but on the right hand side, it is 1 plus 2, which is 3 times tan inverse x. Can you help me with tan 3 theta formula? What was it? So tan 3 theta is 3 tan theta upon minus tan cube theta upon 1 minus 2 tan square theta. Do you remember that result from trigonometric functions? So this is 3 tan inverse x. I hope you remember. I can write it as tan inverse of 3x minus x cube. I hope you remember S1 minus S3, which is x cube, upon 1 minus S2. I hope you remember S2 will be, I hope you remember x square plus x square plus x square, which is going to be 3x square. Do you remember all of these results? Now, sir, why are you not bothered about the other results? Why are you not taking care of other results? Why are you simply replacing 3 tan inverse by this only? Because I have this particular result with me. Not just that, I could draw some more conclusions by using my own intelligence as well. What do I mean by my own intelligence? See, if tan inverse x is between minus pi by 2 pi by 6, can you help me with 3 tan inverse x? If I multiply all the sides by 3, it will be minus pi by 2 to 3 tan inverse x to pi by 2. So the range is already satisfied. Look at the LHS. LHS is given as tan inverse y. So when you talk about tan inverse y, it should lie between minus pi by 2 pi by 2. Because tan inverse y tells you whatever y is going to be, but it can never go beyond minus pi by 2 and pi by 2. It should lie between minus pi by 2 and pi by 2. On the basis of this, is this RHS also lying between minus pi by 2 and pi by 2? Yes. They have actually helped you in the question only while giving you this mod x as less than 1 by root 3. And through this also, the RHS, which is 3 tan inverse x, is also between minus pi by 2 and pi by 2. So the data is already in sync. I need not do any adjustments to, make it lie between that values. I hope you are understanding it. So that is already happening, and that's the best part. So from here, I can directly compare and say that if tan inverse y is equals to tan inverse of this without any adjustments, then y is undoubtedly going to be 3x minus x cube upon 1 minus 3x square. Did you get that? Are you able to understand this particular chapter more clearly? And that's exactly what we have, 3x minus x cube over 1 minus 3x square, option B. My concern is that yes, formulae are very simple. You can remember them, you can learn them, you can derive them from the previous chapter only. The more clarity you have from the chapter trigonometric functions, the better you are at with the formulae at your fingertips regarding all the formulae which we have, identities which we have discussed in the chapter trigonometric functions, the more clarity you'll have here in this particular chapter. That's exactly what you are doing, but from the inverse functions perspective, that's the only change. Now, if I could tell you more, if I could discuss more things, this is again nothing but what we have discussed, the other versions of tan theta. I'll write it here. Do you not remember in that previous chapter, in that previous one shot only, we have discussed the formula of tan 2 theta as 2 tan theta upon 1 minus tan square theta. But did we not discuss that as 2 sin theta upon 1 plus, sorry, I'm really sorry. I am now going to discuss the formula of sine 2 theta. I'm really sorry. Sine 2 theta. The one variant of sine 2 theta was 2 sine theta cos theta. But the other variant of sine 2 theta was, I hope you remember, 2 tan theta upon 1 plus tan square theta. Do you not remember that? Sir, why are you saying this? Because first of all, we have proved it. And even if you have forgotten it, we can prove it again. I hope you remember tan theta is sine theta upon cos theta. This is sec square theta. So we'll again be left with 2 sine theta cos theta. Now, some of you might wonder that how is it related to this? I can prove it. How? I'll simply try and tell you this thing that, see, what do we need to prove? Can I, for a while, let's say, take tan theta as x, let's say, here, let's say tan theta I'm taking as x. So what result do I have? Sir, on the right hand side, you have 2x upon 1 plus x square. Great. So what is the value of theta? Theta we have written as tan inverse x. Did you get that? Any confusions on that? So here, can I not write this entire expression as 2 theta is equal to sine inverse of 2 tan theta. 2 tan theta means what? 2x upon 1 plus tan square theta, which means what? 1 plus x square. And what is theta? So theta is tan inverse x. So this 2 theta can I not write as 2 tan inverse x. So that's the formula you have gotten. That 2 tan inverse x is sine inverse 2x upon 1 plus x square. But again, there is a condition that this will give me values between minus pi by 2 and pi by 2. But here, this will be between minus pi to pi because it is doubled. So I can take this formula as it is if x is between minus 1 and 1. But if x is greater than 1 or if x is less than minus 1, because 10 can take all the values. I hope you remember 10 is true for all the real numbers. So in those cases, I either need to subtract this from pi or I need to add this to minus pi, which means I need to subtract it from minus pi. I would still insist that at least remember this as a result. These variants you need to learn because there are a lot of variants. You got to learn them. You cannot derive all of them. Again, the other formula, do you not remember that we had discussed a variant of cos 2 theta in terms of, first of all, first one was 2 cos square theta minus 1. The second one was 1 minus 2 sine square theta. The third one was cos square theta minus sine square theta. There was fourth in terms of 10, which was 1 minus tan square theta upon 1 plus tan square theta. Do you remember that? So we know that cos 2 theta is always 1 minus tan square theta upon 1 plus tan square theta. Do you remember this? And again, the way we have proved it previously here, in the same fashion, here also you can prove this result. There also you need to remember that 2 tan inverse x can be written as cos inverse of 1 minus x square upon 1 plus x square, as long as x is negative, sorry, positive. And if x is negative, then there should be a minus sign. Because again, the constraint is that cos inverse will give you values between 0 to pi. But tan inverse x takes values from minus pi by 2 to pi by 2. Although even if I multiply it by 2, it will take from minus pi to pi. So from 0 to pi can be brought here, but minus pi to 0 can be brought with the help of this negative sign only. Did you get that part? I hope you're comfortably understanding all what I'm saying here. So these are those arrangements which are done here to bring the LHS and RHS in sync, in synchronization, right? Now, let me try one more question so that we get more clarity on this front. What is that question? What does it say? It says for x minus 1 to 1, where open on minus 1, closed on 1. Minus 1 is excluded, 1 is included. The number of the solutions of the equation sine inverse x is equals to 2 tan inverse x. Now look at this, how simple this question is. If you know these simple rules, see, I'll keep sine inverse x as sine inverse x only. Do I have any formula to convert this into sine inverse x in terms of sine inverse x? I think we have had a discussion here only that 2 tan inverse x can be written like this only. And this is exactly what I can do, because that is something which you can do whenever x is lying between -1 and 1. So without any hesitation, I'll write it as sine inverse of 2x upon 1 plus x square. So 2 tan inverse x, I can write as sine inverse of 2x upon 1 plus x square. Do you remember that identity, that formula, that property? Along with this, I won't hesitate in writing this directly without any addition or subtraction of pi or minus pi, something like that, because x is between -1 and 1. So as long as x is between -1 and 1, this is exactly what you do. 2 tan inverse x can be written as sine inverse of 2x upon 1 plus x square. Again, very basic funda, that sine inverse of this is equal to sine inverse of these, which means these values are also equal, which means x should be equal to 2x upon 1 plus x square. Now, some of you might want to cancel this x by x. If you're doing it, don't forget that x should be treated as 0, because you don't cancel a variable by a variable. You don't divide a variable by a variable in equations, because when you do so, you make the root laws happen. So in order to avoid that, I can cancel this x by x, but here I need to have the one of the solutions of x as 0. Do remember this. Now, when you have cancelled it, 1 plus x square comes here. There you are left with 2. So x square leaves you with 1 and x becomes plus -1. So I have gotten 3 values of x, which are -1, 0 and 1. But the problem is, what does x say? As per the question, x cannot take -1. So do you not think that I should exclude -1? I should include 0 and 1 only. Do you all agree with this? So I am not left with 3 answers. I'm left with 2 answers, which are 0 and 1. 1 is included, 0 is also included, but -1 is excluded. So there are 2 answers. So they have asked you number of solutions. It will be 2. It won't be 3. I hope you understood why they make you commit such simple errors. They wait for such chances. They do this deliberately, intentionally. And in a rush, once you have done it in the next 2-3 steps, you are very much, what should I say, lured to marking 3 as correct answer, which is not, because that -1 should be excluded. And that's where a lot of genius, intelligent and brilliant students commit such silly errors. That you may end up getting the correct answer, but you may not realize that this is needed to be verified with the domain they have specified in the question. So take care of such nuances. That's where, despite doing the entire question correctly, you end up committing the error. -1 is perfectly acceptable answer to this question, but not to this entire question. Did you get that part? Did you understand that? Now, if I could move ahead towards the next part of this phase, here we have this graph, which I'm simply giving you in notes. I'm not explaining this part. I'm simply giving you in this note so that you remember that the graph of cos inverse of 4x cube minus 3x is drawn like this. Why am I not explaining this? Because this is something which is using the concept of application of derivatives, the concept of monotonicity, the concept of a curve being concave up, concave down, the concept of maxima and minima, the concept of a lot of things which we'll be discussing in application of derivatives. So don't worry, we'll discuss it there only. I'll give you a complete clarity how is it this graph given. But for the sake of keeping it here, because it is a part of ITF, I have given you in the notes. Once you click on the description, the link given in the description, you'll find these notes there. So it is there with you. It will stay there with you in your notes of ITF. But this particular concept in a great detail, I'll explain when we discuss the chapter AOD. So don't worry about that. Right. Now, moving ahead, yes, that's the culmination of this particular chapter, inverse trigonometric functions. The only change which is there in this function, inverse trigonometric function, is it is inverse of trigonometric functions. Both of the chapters are completely related. If you are thinking that, no sir, I am not interested in ITF, it is tough for me, I am skipping this chapter, please don't do that. Most of you, those who have watched this video completely, must have realized that yes, it is not tough if you have learnt the concepts from the chapter inverse functions. Second, who knows, such easy questions can be asked from such a, let's say for a while, tough or complicated chapter, which it is not in reality. But let's say even if it is tough for you, why do you not study it through this one shot or simply revise the PYQs? Because if an easy question is asked, your chances of solving that are high. And +4 is at such a low cost. If it is attained by you, why should you not have it? Are you understanding the reason? So of course, through these one shots, which we are providing you at absolutely free of cost, we are giving you a great clarity of all the concepts, very much comprehensively, very much thoroughly, in the best possible way or manner we can. But what you should remember is that along with these videos, we are providing you these handwritten notes along with the DPPs for your practice in the real-time environment. The kind of environment which you'll be getting while attempting the real test, that same environment we are providing you at no cost. Please avail this. You can avail all of this at absolutely no cost by clicking on the link given in the description. It will redirect you to our PW app from where millions of students are already preparing for different competitive exams at affordable prices. And also they're getting the results. So I think that is it for the day. Let us meet in the next video. Thank you so much. You have been a great audience.